Hello. Good morning. All right, we're going to play the game of waiting for the laptop to turn on. Sorry. Don't worry, I promise this is going to work. Yes. Yes! All right. All right, folks. Welcome to day 2. You all survived day 1. Kudos, congratulations. You didn't stay out too late. It's great to have you back. My name, once again, is Carter Rabasa. My pronouns are he, him, and these are not pictures of mustached influencers, just me and my family. Wanted to, once again, take a moment to remind us to acknowledge that Town Hall Seattle stands on the unceded traditional territory of the Coast Salish people, particularly the Duwamish, and we thank them for the use of the natural resources of their homeland. Wanted to start off day 2 talking about the fact that, CascadiaJS is, hopefully you all agree, is a really wonderful, lovely thing, but it only happens once a year. And there are these wonderful things called Meetups that sustain all of you and sustain our communities throughout the course of the year. So I wanted to invite a couple of lovely people up on stage to tell all of us a little bit about their respective meetups. So who's going first? All right, so go ahead, introduce yourself and let us know.
Perfect, thank you. All right, good morning, everyone. Let me just get my script here because I'm a little nervous. My name is Bibi, and this is my first time. Thank you, that's very nice. So my name is Bibi, and this is my first time at CascadiaJS, and I'm having a really good time with you all, so thank you so much for just giving me your attention. And I want to say thank you to Carter and Carrie for orchestrating this so beautifully, because it takes a lot to put on this whole show for you guys. Okay, on to my main spiel. So me and my friend Anton, I hope he's out there, we organize a meetup called Van.js, and Van.js is short for Vancouver JavaScript, Vancouver, BC, not Vancouver, Washington. And yes, the better Vancouver. I hear booing. Sorry. Yeah, so Van.js has been around since 2009, and we're going strong ever since. We are a community-oriented meetup with monthly events revolving around all things JavaScript. We talk about libraries, frameworks, you name it. We are welcoming new faces and looking for speakers every month. So if you want to dabble with that, or you're just curious and want to visit, feel free to come chat with me after this. I am going to post a link on Discord for you guys to take a look if you're curious. And yeah, hope you guys have an amazing day too. Thank you.
Hello, everyone. My name is Andre, and I'm your local organizer for CascadiaJS. We're a meetup similar to Van.js that gets together to talk about all things web and JavaScript. Actually, fun story, my first Cascadia that I came to was about 3 years ago, and I had no clue about this amazing community, and I came here and had an amazing time, and I was like, made a bunch of friends. I was like, I don't want this just to happen once a year. So I started going to the CascadiaJS meetup, and through that got to keep up with all these friendships that I made at the conference, and 3 years later, here I am now working for Carter behind the scenes trying to put this thing on for y'all. So hopefully everyone here has made some amazing friends and people that you want to keep in contact with. If everyone there is local to Seattle, come join us at the meetup to keep up with those friendships, or maybe travel up as a friend group to Vancouver to go to Van.js as well. That could be really fun. We meet up on the second Wednesday of every month. So that puts us at July 10th for the next one at Silicon Valley Bank here in downtown Seattle. If you want all those details or you forget about everything I just said, always go to CascadiaJS.com for all those latest details, and I'll post that in the Discord as well. So hope to see some of you there later today. Come say hi if you're around, and hope to see you next month for sure. Thanks.
Awesome. Before they leave the stage, can we all just give a huge round of applause to all the Meetup organizers in the world, because they do the best work ever. All right. Thanks, guys. And by the way, if anyone knows anyone that runs JavaScript meetups down in Portland, please connect them to me, because I would love to have them up here. I've been around for like a long time, and I used to know about meetups that stopped happening during COVID, but I don't live there anymore. So if there's new stuff happening, please let me know. Sincerely, like I kind of just think of CascadiaJS as like an annual family reunion of people who otherwise are going to all of these JavaScript meetups up and down the Pacific Northwest, and it's just a great opportunity for us all to get back together. Moving along. Hey, raise your hand if you did not get a hoodie when you registered. Okay, all right, well, this is for you. So we have extra hoodies. So we are going to give away the extra hoodies at the closing party. So if you didn't need more motivation to stick around for the closing party, stick around for that. And by the way, also, if you got a hoodie and, I don't know, it just doesn't fit or something, we can do exchanges too. So our goal is to leave tonight with not one hoodie left over, so please come grab one. Once again, all the good social stuff. It feels so great to look at all of the amazing photos that you all are sharing on social media. Like, that's like, there's a lot of awful stuff about social media, but like, that's the good stuff, right? So please feel free to post stuff. Please use the hashtag. It makes it easier for us to find it. Makes it easier for you all to kind of find each other. So yeah, keep doing it. Discord. Discord, especially for all of the folks that are watching online. By the way, we had like, I haven't done the full count, but I think we had like over 600 or 700 people watching the stream yesterday. So hello for all the folks who are not physically here. The Discord is for everybody. So if you're here in person and you want to talk, you want to ask speakers questions about their talks, we're creating threads in the live stream channel. If you have a question and you just can't find an organizer, ask it there. Like, we're monitoring this channel as best as we can, so definitely make use of it. Let's see, and oh yeah, and then the scavenger hunt. Just FYI, we're doing the last call for people to turn in their scavenger hunt cards at 4:30. 4:30 is basically like the last break before the final stretch of talks and the closing ceremonies. So definitely get your card filled out and turned in by 4:30, and then I'll be doing the raffle drawing like live here on stage, and it's gonna be really, really interactive and super, super fun. So I think you'll love it. And now I'm gonna welcome back to the stage our very own Daphne Oakes. Round of applause.
Hello. Hi, it's me again. I don't know if there's any Daphnes in the audience, but just from yesterday, talking to people, I realized that I'm still the better Daphne. So here's the agenda, very similar to yesterday, talks and break and lunch. But the different thing today is that we are going to have a closing party. Oh, I know, today's the last day. It's really sad. But we're going to end on a high note. We are going to have karaoke. Super excited. Yesterday, I kept on asking everyone what song you're gonna sing, so very excited to hear that tonight. Next up, oh, actually, before that, just so that I get you properly warmed up, did everyone have a good rest yesterday? Yeah? Okay, I can't hear you. Yes, you're ready to go? Oh my God, it was honestly so nice meeting you all yesterday. And after talking to you guys, I realized that apparently my mic was on at one point when I was backstage. Yeah, so now every time I go back, I have to do like a countdown, so make sure I don't say anything. But anyways, cool. Let's play a warm-up game. This is called Is It AI or Elon? So here's how it's gonna work. I'm going to read out a couple of quotes, And as an audience member, it's your job to guess whether it's AI generated or did Elon Musk say it. You know, sometimes you just don't know. All right, this is the first one. I think it is possible for ordinary people to choose to be extraordinary. AI or Elon? That was Elon Musk. Okay, that was a warm-up. The next one. Why build rockets to Mars when we can build AIs that dream of electric sheep? Are you guys sure? AI? Okay, so we got the Elon and then the AI. Okay. The answer is? Oh, I'm sorry. 1 point for this side. I guess I'm making you guys go against each other again. Okay, next one. If your AI isn't rethinking its existence at 3 a.m., you need a better algorithm. What do we? Oh! Oh, okay, yeah. Oh, you got it right. You got me. Okay. Wait, did all the animations stop working? Okay, that one is working. Oh, thank God. Okay. Some people don't like change, but you need to embrace change if the alternative is a disaster. Oh, AI. Okay, so with like a small group in the center that says A. Okay, but mostly Elon, I'm saying? Cool. Okay. Yes, you got it right. Good job. All right, we're doing great. I think this is the last one. Oh, why is the animation not working? Okay, yeah, I would like to die on Mars, just not on Impact. Who is it? Oh. We have one person who doesn't trust my slide. Okay, cool. So that's it. You guys are great. We're so excited to bring out our next speaker. Welcome to the stage, Dominic Ferolino. Our very first speaker today, everyone says, "Hi, Dom." So this is Dominic Ferolino. He's a software engineer at Google on the Chrome team. So he is basically Dom working on Dom Center at a company that dominates tech industry. I could be Dr. Seuss if I want to. So he has worked on Chrome, Firefox, and at Microsoft. He's collecting browser experience like he's Thanos. And Dom is a runner, he's a track star. He's a former juggler. I actually was going to bring some balls and see if you can still do it.
No, the answer is no. Former is correct.
Okay, no, okay, that's why I say former juggler. And he's here to talk about Observable API. Without further ado, Dom.
Awesome. Okay, thanks so much for joining me for the first talk of the day. I'm super excited to talk about this new primitive that I'm trying to work on bringing to the web platform called the Observable API. But before we get started, let's get to know each other, or at least you can get to know me. As Daphne said, I'm Dominic Ferolino. I actually go by Dom, but I introduce myself as Dominic because I find that if I say Dom Ferolino, people think I either say Don Ferolino or Tom Ferolino. It's always wrong. It's never the right thing. So I just keep it easy. But yeah, I'm Dominic Ferolino. You can feel free to pull out your smartphones or your flip phones or your Abacus and follow me on either Twitter or GitHub or something. I usually post about web APIs that I'm excited in or involved with myself. As Daphne mentioned, I'm a software engineer on the Chrome team at Google. I work on the web platform. I work mostly on DOM APIs for legal reasons, because of my name. That's a joke. Also for legal reasons. But I also work on a lot of web standards in the What Working Group standards organization, if you're familiar with that. Okay, so what is this talk? We're going to be talking about observables, but in order to really dive into observables, we first have to give a brief overview of just what async means on the web platform. Then we can talk about what an observable is and how the guts of observables work under the hood. And throughout the talk, we're going to see a ton of examples of observables in action and how to use them and all kinds of stuff. And then the last two bits are really important. We're going to talk about how to unlock the full power of this primitive through operators on the Observable API. These are just fancy words for methods on the Observable API. And then finally, we're going to talk about disposing of resources and unsubscription and so on. So let's get started. To talk about async on the web, we first have to talk about promises and callbacks. So JavaScript is a normal language. It executes from top to bottom. You can use the result of a bunch of async work as early as the next line of code. But things get a little more hairy when you do async work. When you schedule some async code, you don't get access to that async value, and you can't use it on the next line of code. So JavaScript solves this by allowing you to pass in callbacks. And the callback is what runs sometime in the future when the result of that async work is available. But the problem with this is that you have to stuff any of the program that depends on that value like inside this new callback function, which is kind of annoying and kind of tedious. It breaks up your program, and it gives you this really non-linear control flow, which is unfortunate. And this is all a result of this leads to what we call callback hell in JavaScript, right? When you have an async value that depends on an async value that depends on an async value, until finally you can do the thing you actually want to do inside. And this is all the result of, for a long time, JavaScript never had a synchronously available handle that represented async work. This was, of course, until promises, which allowed us to write code like this. We can immediately get access to this value that is returned from the result of scheduling async work, and then we can immediately call methods on it like .then and have our pass in a callback that produces the value. But we're still dealing with callbacks, so it doesn't feel like we're really out of the woods yet. But the magic with promises is that, of course, each then handler returns a promise. So if we want an async value based on an async value and so on, we can chain these together and mostly reclaim our linear control flow. And this is great, but the problem is we can't do this with events and event handling on the web yet, right? Promises are awesome. We love them. We use them every day, but they have some limitations. The first one is that they're single shot, right? They're one shot. They only produce a single value at a time, and then they're done forever. So if you have a promise that represents the click events fired at an element, for example, your promise is only going to be able to emit a single click event one time, because the resolve function can only be called once. And that's an issue with events. Usually you have an arbitrary stream of asynchronous events that you have to process. But the second limitation is that they have forced scheduling inside. So if we go back, and maybe you're okay with having just the first click event, and that's what you can deal with, and you can call .then on that promise and handle the event accordingly. The issue with promises is that by the time that callback actually runs, by the time you get access to that value, it's already too late to do a lot with it. I mean, you can print it and you can introspect some of the values and so on, but you can't do a bunch of things like prevent the default behavior of the event and manipulate its flow as it gets dispatched throughout the DOM. And that's because this always runs asynchronously after the event is fired. So the result of this is promises are not really a good partner or API with event targets on the web platform, which means we're stuck with basically the old school APIs on event target, like add event listener and remove event listener and so on. And this gives us into like a version of callback hell, which I call add event listener hell. And we're going to show you an example of this in action. Maybe you probably know what the Konami code is. This is like an old cheat code injected into like a lot of old Japanese video games and so on. The pattern's probably pretty recognizable, like up, up, down, down. I mean, you got it. It's right there. So imagine you wanted to make a website that listened for the user typing in the Konami code, right? You'd probably write some code that looks like this. It's a little messy, so we'll step through it line by line. The first thing you're going to do is just add an event listener for key down events on the page. But only one time, because we just need to see if the very first key pressed matches the first key in the actual Konami pattern in this case. If so, we can continue. We'll create a new handler for every subsequent key press, and immediately add it to the document as the new event handler. And this handler needs to tear itself down and basically destroy itself in two scenarios. The first is if the pattern ever stops matching, if the user types in something wrong. And the second is if the user has only typed in right things the whole time, and we get to the end, we can log a success message and then be done. This isn't terrible, but you can see for such a simple example, we have 3 nested calls to event listener APIs. If you forget any one of them, you either get a memory error, or sorry, a memory leak or a logic error or something like that. It's real fragile. So I'm here to tell you that observables, this new reactive primitive that we're working on bringing to the platform, will save the day for examples like this. But first we have to know what an observable actually is, okay? So observables are kind of like promises for multiple values. That's roughly correct, but that's the scaffolding I want you to have in your brain for now. But there's 2 big takeaways with the API. The first is that they are the synchronously available handle that represents an arbitrary stream of events that can be dispatched at any time. And you can immediately manipulate future events in this stream with the powerful operators that come on this API. But the main takeaway here is that observables were designed with event target integration in mind. And so a snippet from our spec looks like this. We're actually introducing a new method to the event target interface that returns an observable. It looks kind of like add-event-listener. It takes an event type, but it doesn't take a callback. It just returns an observable. Now, in this snippet, we're calling the method on, but I have some terrible news for everybody in the community. There's probably a really good chance that, like, literally maybe today, we're going to have to rename this API to something else that doesn't conflict with a bunch of libraries that we're going to break if we ship this in Chrome and in other browsers. And the on method was the reason I got in this game in the first place. So I'm pretty bummed. We're going to host calling hours and a service after the session to mourn the loss of this API. So we could just take a moment of silence for that. But anyways, whatever the API is called, you'll see on in this talk. But its intention is to be a better add-event listener. And we'll show you some examples. So you can use the on method in this example to get an observable that represents the stream of all click events that can be fired at this element. Now, you probably don't want every single click event, so maybe you want to filter some of them out. This is where the observable operators that we're going to cover later come in. You can call filter, which gives you a chance to pass in some filtering criteria. But the powerful thing about this is that the operator here, in this case, returns an observable itself. So you can call other operators on it, like map, which allows you to, in this case, map the event object into like a bare bones object with just an X and Y for the click coordinates in this case. And that also returns an observable, which means you can call sort of like the master function on this at the very end called subscribe, which lets you pass in a callback and process the event accordingly. So you get this nice linear declarative flow that the events, whenever they come in, will flow through, and you don't have to deal with a lot of nesting and a lot of manual teardowns and so on. So eventually someone clicks on the element, an event gets created, it goes through the filter, and as long as it passes the filter, it'll only then go to the next operator, map, in this case just, again, maps it to a straightforward bare bones object, and then it finally goes to your subscribe handler. And you only get the mapped and filtered out values that you wanted at the very end of the pipeline. So now let's figure out how we can fix the Konami example with observables. So you can imagine we'd want an observable that represents the stream of all key down events. But we don't care about the events themselves. We really just care about their event names, so we can just map the useful information out of them. And we don't want every key down event. We probably just want 10 or 12 or however long our pattern is. So we'll just take the first n number of them. And we can use other operators to check that every key pressed has an index that matches the key in the corresponding pattern, and so on. And then at the end of all that, we can get a signal as to whether they all matched or not, and we can log a success or an error message accordingly. And it's much simpler. We don't have to deal with nested remove or nested add event listeners. It tears down itself. It's really easy to audit to make sure it's right. And that's what we're working on introducing here. So that's a brief example of an observable in action. I want to talk about how they work under the hood and how you can make your own. So I told you observables are like promises. And promises have like producer and consumer code. Right? The producer code is the callback function that goes into the constructor. It gets this resolve function, and you can call it, in this case, with the value 10, and the consumer in the .then handler gets access to it. Observables are very similar. The producer code also goes in the constructor, but they don't get a resolve function. They get this subscriber object. And they don't call .then, but they call something else called .subscribe, of course, after you use this API. So with your subscriber object, you can call the next API to push arbitrary numbers of values through the consumer, which uses a subscribe function. Looks really similar to promises, but there's some key differences here, which we'll cover in a bit. But the first difference is this next method, right? It's kind of like resolve for functions, but for promises, but you can call it an arbitrary number of times to push values. But what other APIs on the subscriber object do we have access to? Here's a snippet of the subscriber interface in our observable spec that we've been working on for about a year now. Like I mentioned, we have the next method, which is kind of like resolve, but you can call it many times. We've got error, which is like reject, and we've got complete, which tells the consumer we're never going to call next again. This is a more elaborated version of how observables can look. You can pass in a single callback, or you can pass in an object that has corresponding named callbacks for the next, the error, and the complete handlers on the subscriber object as well. So this is sort of the full version of that. But there's a huge difference between promises and observables that's been right under our nose the whole time, and it's the fact that observables are lazy. This is in contrast with promises being eager, and what I mean by that is when you construct a promise, that callback runs immediately. The promise is already on its way to resolving or rejecting before you even have a consumer. And observables are the exact opposite. This callback function doesn't run right away. In fact, it only runs once you subscribe to the observable with the subscribe method. And this is in part because observables are multicast. So you can actually call subscribe an arbitrary number of times and invoke that function and get basically a new subscription for every single time you call the observable. And so just to kind of recap what we're seeing so far, this is roughly what we have, the difference between promises and observables so far. Observables can emit many values, they're lazy, and that is due to, in part, them being multicast, whereas promises have a single consumer and a single producer at any given time. I want to just walk through an example of a native event listening observable in action. So imagine you've got some HTML, you just have a simple button. Under the hood, the browser is going to maintain this event listener map. It's basically a map of event types to registered listeners that can handle events of that type. Now imagine in JavaScript, you create an observable that represents all click events that can be fired on the button. What this is going to do in like the C++ or Rust or whatever in your browser is it's going to create an observable object under the hood in native code. And observables are created with producer functions, so it has to have a producer function. This is going to be like in C++, but I'll show you the JavaScript equivalent of what the producer is going to do. Basically, all it's going to do under the hood is whenever it's subscribed to, it's going to add an event listener, and it's going to forward every event to the subscriber. It's an ergonomics thing at this point. So eventually, you're going to want to subscribe to that observable. You actually want to start handling click events that get fired on the button. So you'll call subscribe, and you'll pass in a next handler. And again, that's going to execute that callback function. It's going to add an event listener inside the event listener map, and that's going to set up the rest of the pipeline through which all click events will flow. Some point later on, someone's going to come by, click the button. That's going to generate a new event. It's going to go through the map. It's going to find that the registered event listener is actually the observable. And the observable callback, as we had written, is just going to get forwarded straight to the subscriber, goes to the next handler, and in this case, it just gets logged. So at this point, it seems really similar to add event listener. The key takeaway here is that this is all synchronous. Unlike promises, there's no asynchronicity built in. So in the same, when we log the event in this case, we're in the same exact call stack as we are when the event is dispatched. So we can call, prevent default and stop immediate propagation and all the other APIs that can influence the flow of the event. And that is the key. That is one of the key differences between observables and promises, is the scheduling. Promises have this built-in microtask asynchronous checkpoint, whereas observables are fully synchronous. You can build in scheduling if you want, but it's not there by default. Okay, so the last two pieces of this talk are really important. You saw me in a few examples use a bunch of operators, right? Like filter and map and take and so on. And I want to talk about where these actually came from and how they can really help you unlock the full power of this primitive. So the list of operators that we decided to include initially with the observable proposal for the web platform is derived from TC39's iterator helpers proposal. This is basically a JavaScript language spec that says, hey, anything that's iterable, anything that can be run over with a for loop, should have these APIs implemented natively by the engine under the hood. So any array or anything that implements the iterator protocol can be mappable and filterable, and you can take the first n values and so on. This allows you to, without having to worry about where these methods actually live, you can just call map and map values to their doubles, or filter even values out, or do more complicated things, even like flat map. Flat map, if you're not super familiar with it, flat map basically allows you to take a single value and map it to a collection of values, in this case, another iterable. And flat map under the hood is responsible for flattening that out into individual values, which is how we map 1 to 3 values based on 1, 2 to 3 values based on 2, and so on for 3. Now I want to show you how this looks and how these operators work under the hood in observable land. I think that's for me. Can I grab that? So here's a quick example of an observable pipeline with some operators. We've got some code gaps here. We're going to fill that in a bit. But first things first, we have an observable at the top. So let's just say it's responsible for emitting arbitrary whole numbers throughout its lifetime, just asynchronously whenever. First thing we're going to do is filter the even ones out, and we're going to call flatmap. So when we called flatmap on values in an array that turned individual values into an array, with observables, we're going to turn an individual value into an observable that emits more individual values. That could go on forever, like literally. So we're only going to stipulate, we just want 6. We're just going to call it take 6, and then we want to subscribe to the first 6 of these numbers. So let's see what happens. The first number will come in from the observable. It's subject to the filter. It's not even, it's odd. And in this case, it passes the filter. It goes down to flatmap. And again, flatmap, in this case, we're going to derive a brand new observable that just asynchronously, whenever, takes 3 values based on 1 and emits those. So that 1 becomes an observable with 3 values. And maybe later on, in some idle time, the first one of those is emitted. It goes through the take operator, which ensures that we only take 6. We're not at our limit yet, so we can log it safely. Let's say before 1.1, the second value gets emitted, though. A second value comes in from the outer observable. It fails the filter, so we just drop it dead here. And then maybe later the second value is processed, and it gets logged to the console, and so on. But before the last value, maybe we've got a third value that comes in, and it's actually odd, my gosh. So it passes the filter, and it's going to go to flatmap, but notice we're not actually done processing values in that inner observable quite yet. So we're going to put that number 3 on ice, and we're going to wait till asynchronously later that observable emits its final value. It goes through, gets logged, and notice the call to complete. It completes itself, telling flatmap to move it out of the way and make room for the next queued value. And then the next observable is processed. In this case, we'll just put all 3 values right through the logger. And the only thing that is special here is that when that third value goes through and finally gets processed by the subscriber, take knows how to complete itself, basically, under the hood, which is going to tell the original producer, hey, stop producing values, I don't care anymore. and it's also going to fire our complete handler. So that's just a rough example of some of the operators and how you can use them with asynchronous streams of events and observables. We have a full list of operators in our spec. Some of them return observables, some of them return promises, and this screenshot's almost certainly out of date, so you should check out our spec, which there'll be a link to at the end for the latest. The final thing I want to talk about is resource disposal and teardown and unsubscription. So you can imagine an observable that every single second it just emits a value until the inevitable heat death of the universe or until your power dies or something. You probably want to subscribe to these values, but probably not all of them. Maybe you just care about the first 100 or so. And so you have this code that basically is dead code for every value after the 100th. And that's really wasteful because the observable is just not going to stop producing values. So we need a way to signal from the consumer to the producer, hey, please, I don't care about any values anymore. Stop sending them. So the first thing we need to do is set the producer up to tear itself down. We're going to get the token returned from setInterval, and we're going to use the add teardown method to say, all right, consumer, when you want to signal to me that you're done, I'm going to clear the interval and stop producing values. And so that's half of the equation. Now we just need the consumer to tell the producer how to do that. And on the web platform, this kind of signaling mechanism is usually with an abort controller and abort signal. So inside that dead code, we're just going to abort this new abort controller. And the key to actually wiring this up with the producer is by subscribing with that controller's signal. So that eventually in the future, when we do call abort on the controller, when we're no longer interested in values, the producer knows how to tear itself down. That's the kind of the verbose way of doing it. So I want to talk about these terminating operators that make that a lot easier. Things like take and take until and first. So here's that same exact observable, but if you don't want to write all that verbose code, you don't have to subscribe directly to that observable. You can subscribe to an intermediate observable, in this case, the take 100 observable. When you subscribe to it, it actually just subscribes to the original source, but it uses that whole signal mechanism under the hood so that in the future, when the 100th value is hit, it actually knows how to cancel itself, tear itself down, tell the producer to stop, and then fires any complete handlers that you might have passed in. And that's kind of how these terminating operators make it super simple to tear down without having nested functions and so on. All right, so we made it pretty much to the end. That's basically all I've got to share when it comes to the Observable API. The last thing I'd like to do is leave you with a request for some engagement. We've got this GitHub repository that we've been working on the observable spec and the Observable API. We've had tons of super awesome engagement with the community, and so we would love for you to reach out and tell us, where we're wrong and what use cases we're missing and what operators you might think are super critical to include so we can get this right the first time. The last thing I'll say is that we also have an experimental implementation of observables inside Chrome. You can actually flip this flag on and run all the code examples inside our repository. And this repository has been worked on by myself as well as Ben Lesh, who's the almost sole maintainer of RxJS, the most popular userland observable library in JavaScript. That's pretty much it. If you want to follow along the progress of this API and so on, I would really encourage you to come and follow me on Twitter. I post about this kind of stuff as well as other APIs a lot. We'd love to get more engagement and to have the developers get really hyped up about this primitive that we're basically trying to use to make add-event-listener extinct forever. At least that's my personal goal. So with that said, thank you very much for listening. Appreciate it.
Good job. Our next speaker is Jeff Rich. He's a Svelte.js maintainer, and since Svelte 5 is coming soon, he is so excited about it, like he's got ants in his pants. Speaking of which, One time, he literally had ants crawling in his pants. He was forced to strip in front of a large group. So I had a talk with him on the code of conduct at CascadiaJS. He won't be doing that today. So Jeff has a music minor, and he's got 2 cute cats, Percy and Oliver, and he enjoys gardening. He loves Svelte, but do you know what he loves more? This incredibly large zucchini from his garden. Give it up for Jeff.
All right, hello everyone. I'm Jeff. It's really great to be here. I've lived in Washington almost my whole life, and it's really great to have a conference like CascadiaJS where I don't have to fly anywhere, I can just stay local. So Svelte is a JavaScript framework that I contribute to, and today I'm going to be talking about what's changing in the next major version of Svelte and why. If I could just have a quick show of hands, like how many people actually know what Svelte is? Cool, pretty good. And then keep that hand raised if you've used Svelte in a project, be it personal or at work. All right, a little fewer. So let's level set a little bit. What is Svelte? So Svelte is a compiled, batteries included, HTML-first JavaScript framework that prioritizes vibes. So yeah, big sentence. We're going to break that down bit by bit. First, compiled. If you know anything about Svelte, it's probably that it's a compiler. So a compiler is a program that takes code written in one programming language and transforms it into another. In Svelte's case, it takes Svelte component code, which looks similar to HTML, and transforms it into tightly optimized vanilla JavaScript. Now, this was a super unique approach to front-end frameworks when Svelte first came out in 2016. These days, having a compiler in your framework is a little bit less unique. Solid.js, a lot of you might know, they use a compiler in ways similar to Svelte, but they use JSX as the template language of choice. Vue has had compiler-driven optimizations for a while now. They're also working on an experimental Vapor mode that will let them drop the virtual DOM completely in favor of using a compiler. And of course, last month, React open-sourced their experimental compiler, React Forget, so that you can stop hand-optimizing your React component rendering. But something that I think makes Svelte special is that we are compiler-first and compiler-only. Compilation is not a separate mode of the framework for us or a special flag. It's fundamental to the framework. Svelte components don't need to run in the browser as is, so we can start with what we want the authoring experience of a Svelte component to be and use the compiler to make that possible. This results in component code with very minimal boilerplate and also lets us make a ton of performance optimizations behind the scenes that result in small, fast web apps. So, compiled. Svelte also aims to be batteries included. Instead of only being a component framework, we also provide solutions to common web app concerns like scope styling, input bindings, intro and outro animations, and accessibility warnings, and even Spring physics. Svelte is also HTML first. We think HTML is a pretty good language for describing UI, and we want writing Svelte to feel like writing HTML. Whereas React starts with JavaScript and adds HTML to it with JSX, Svelte takes HTML and enhances it with JavaScript reactivity. We also prioritize Svelte's unique vibes. Being small and fast is great, and those are definitely priorities for us, but what we optimize for is how it feels to write Svelte and the aesthetics of it. And vibes is something we're going to come back to as we talk about the next major version of Svelte and what's changing, because I think optimizing for vibes is a key part of successfully making a breaking change. Part of making a change like this, and we'll get to what that change is in a second, is making sure that the project after the change still feels like the same project. People get attached to the vibes of whatever framework they use. And if you're changing your framework, you want the vibes to be the same, or at least similar. Because if you make a breaking change and it feels like a completely different framework, well, maybe you should have just made a new framework. But we don't think that's true with Svelte. Despite the significant changes coming in Svelte 5, we still think it feels like Svelte, and we hope our users do too. So for many of you who haven't actually used Svelte before, this is what a component currently looks like in Svelte 4. A lot of this will be changing in Svelte 5, but the shape of a Svelte component will remain, and less may change than you might think. So as I mentioned, Svelte components look like HTML. Here we have a simple counter component. At the bottom, we have the template for the component. We're rendering a button with a click handler, some text, also listing out what the value of count is as it changes. And the logic lives in the script tag at the top. You can also have a style tag containing styles scoped to the component, but we're going to mainly focus on the script section today. On the first line, we use export let to define a component prop, in this case a text prop to set the counter button's text. You can also declare component state, just like you would a normal JavaScript variable with let. In this case, we're defining a piece of state called count that we use in the template by wrapping it in curly braces. Importantly, and what a lot of people like about Svelte, is that you can update that state variable directly without needing to use a setCount function or other framework abstraction. When we call count++ here, the DOM will automatically update with the new value of count. You can also define derived values using this $ label syntax. In this case, we're creating a variable called doubled and saying that it should always be 2 times the value of count. Whenever we update count, Svelte will automatically update the value of doubled as well. $ can also define what we call a reactive block, where you can run some code after any of the state variables referenced inside the block change. In this case, whenever count is updated, this block will run and log a message if count is greater than 10. So Svelte works great today. A lot of people love Svelte. It's being used in quite a few production applications. But it's been a little bit since Svelte 3's release in 2019. It's been 5 years. And so as the current API got more and more usage, we noticed some areas of improvement. 5 years is also a long time, especially in the web dev world. 5 years ago, React had just released hooks. If you were writing React, you were probably doing so using Create React App. And let's be honest, that app might still be using Create React App. Vercel was known as Zeit. Vue was still on version 2 and only just proposing what would become the composition API. Solid.js wasn't well known yet. Microsoft Edge was still using its own browser engine instead of being Chromium in a trench coat. And if you were unlucky, you still had to support Internet Explorer 11. Think of how much front-end frameworks and the front end in general has changed since then. So with Svelte 5, we're taking advantage of all the learnings and innovation that's happened in the space through other frameworks in the browser, and using them to make Svelte even better than it already is. So what does that actually mean? Summarized, Svelte 5's main goal is universal runtime reactivity. With this change, we hope to make Svelte more scalable and able to tackle projects of any size, and also make Svelte's mental model more consistent and easier to learn. Let's start with universal reactivity. Today, Svelte has 2 reactivity modes. There's the easy-to-use reactivity model inside Svelte components that I just showed you, but that reactivity model doesn't work if we try to move it to a separate file. Let's take another look at the example I just showed. Let's say you wanted to wrap this counter reactivity code into a utility that could be used anywhere. You can't just copy-paste the code into a JavaScript file or even move it into a function inside the component. Svelte's reactivity only works at the top level of Svelte components. Instead, to move it, we need to rewrite it to a completely different reactivity API called stores. Now, I'm going to show an example of what that might look like, but just fair warning, don't worry about actually understanding the code. The details aren't the point here. Just notice what I've highlighted in red. This is what you had to change in order to extract the code from the component. And that's a lot to change just so that we could share this reactivity between multiple places. And because that makes refactoring difficult, Svelte components often grow larger than they need to be. But what if you could just copy-paste that reactivity code into a different file and it would work? What if we could use Svelte's component reactivity model everywhere? Well, that is what universal reactivity in Svelte 5 is. But before showing what that actually looks like, let's discuss the other big change, runtime reactivity. Svelte 5 moves from compiler-based reactivity to runtime reactivity. Svelte 4's reactivity uses compile time static analysis. The compiler analyzes your code to determine which variables you're updating where, and then adds code to invalidate data at the right time. This works well most of the time, but there are some extremely tricky edge cases that are hard to solve with a compiler-based model. It makes other kinds of refactoring tricky as well. For instance, let's look at this reactive statement from earlier. Let's say that doubling a number wasn't as simple as doing count times 2, but it was some sort of verbose operation that you wanted to move into a separate function. In Svelte 4, if you do this, you'll actually break Svelte's reactivity, and doubled will no longer respond to changes in count. Doubled's dependency on count is now invisible to the compiler. Instead, and a lot of Svelte devs learn this when they're first starting off, in Svelte 4, you need to pass count as an argument so that the compiler understands that this function should rerun and update doubled when count changes. But that can be unintuitive, and it's easy to miss as the number of variables your reactive statement depends on increases. So in Svelte 5, we're changing this. Svelte 5, the compiler is no longer responsible for determining reactive dependencies. Instead, those are determined when the code runs in the browser. Now, this doesn't mean that Svelte is dropping its compiler. That's far from it. It's just not using it for reactive dependency tracking anymore. And we'll talk a little bit more about the implications of this later. So this is what Svelte 5 aims to deliver: universal runtime reactivity. Now, enough theoretics. Let's see what that looks like in practice. It's time to talk runes. So you might have heard the phrase runes before. This is the new way to express reactivity in Svelte 5. That same Svelte 4 component that we just looked at would look like this in the new reactivity system. Let's break this down. So in Svelte 5, those function-like symbols starting with a $sign are called runes. But they're not actually functions. You don't import them to use them. Instead, think of them more as instructions to Svelte's compiler. These runes replace Svelte's existing reactivity syntax. So instead of export let in Svelte 4, props are now destructured from a props rune. State variables are now declared with a state rune. Under the hood, the state rune will use something called a signal, so Svelte can perform targeted updates when this value changes. However, as far as the component author is concerned, count is just a regular number, and you can access and update it just like you would any number in JavaScript. It's not a special reactive object or a function that needs to be called. It's just a number. This is important for vibes reasons, and we'll talk a little bit more about this later. Instead of that $sign label syntax, derived values now use the derived rune. And our reactive block turns into an effect rune, which will rerun whenever any of the reactive variables inside it change. So on the surface, this may look like mostly a syntactical change, but let's talk a little bit about how it solves some of the issues from earlier. First, unlike the $sign label, derived and effect use runtime reactivity. So we can now safely refactor into functions without breaking anything. If you're using Svelte today, you don't need to learn that gotcha I mentioned about passing in reactive dependencies as arguments. With runes, we also now have universal reactivity, which means it's much easier to refactor this reactive counter into a separate file if we wanted to share it between components. Earlier, we showed how to do this in Svelte 4, and it involved rewriting to a completely different, more verbose reactivity API called stores. But in Svelte 5, not only is the reactive logic more concise than the store version, it can also be copied into a function verbatim. If you look at this function, this part highlighted in green is exactly the same as what was in the component. There's no need to convert this code into a different API. The only change is that the function now needs to return data for the component to use. And actually, let's take a closer look at what we're actually returning here, because that may look unfamiliar to some of you. Those function-like values for count and doubled are called getters. In case you haven't seen this before, it's nothing Svelte specific, it's just JavaScript. A getter is a special object function that maps to a property. When we access the count property on the returned object, it runs this count function to get that property's value. And this is important because we want to get a live reference to the count state. Remember that when you interact with count, it's just a number. And if we just returned a number here, then there would be no way to update that number after we returned it. Instead, we always want to get the live value that the increment function is updating. And that's what the getters give us. They let us return the same underlying value that the increment function is operating on and let us keep those in sync. So when wrapping up reactive state like this, you can use objects like I showed, or you can also use classes. This is also a valid way to write that same counter with count and doubled as reactive class properties. Either way, these can be used similarly. You can import them into the component, call them, and then use the values in your script tag. A lot of syntax here. I'll definitely give a link to the docs and my slides after the fact, so don't worry about capturing all this right now. So I talked earlier about how when planning this change, we wanted to make sure to preserve Svelte's vibes. So now the question is, did we succeed? Well, I think only the community can really decide that. For the most part, feedback has been positive, and people are excited about Svelte 5. But if anything looks less Svelte-like to you, It's probably that you now have to type state out instead of it being inferred. Why do we have to do that? Well, technically, we could have switched to runtime reactivity without changing the syntax. But we also wanted to unlock universal reactivity. And if we want to be able to declare state outside components, we need a way to declare it explicitly. We were able to get away with implicit state in Svelte 3 and 4 because it only applied to variables at the top level of a component. So in this Svelte 4 example, name and numbers, they are reactive state variables because they're at the top level. But sum and value are nested inside a function, so they're not reactive. But in Svelte 5, state can be anywhere. It can be at the top level of a component. It can be inside other functions, inside other files, or even inside other functions inside other files. And if we assumed every let was a state declaration, like in Svelte 4, it would get very confusing to figure out if a variable was truly reactive or not. It would also have a performance impact. Making a value reactive isn't expensive, but it would add up if we applied it to every single variable in Svelte files. It also brings a readability benefit. Code is read more often than it's written, and now you have a clear visual signifier as to what is state and what isn't. And if you're concerned about saving your fingers, well, isn't that what editor autocomplete is for? Now, if the word state makes people nervous, there's one other word that might frighten people. Effect. And I don't think effect needs to be a scary word. Maybe this is better? Svelte had effects before now in the form of reactive blocks. We just didn't call them that. Side effects are a natural concept in reactive UIs. They're often overused. Our docs encourage using derived state instead where possible, but they are necessary. And there is one important thing to note about Svelte's effect. Unlike useEffect in React, there's no dependency array. If you're familiar with Vue's watch effect or Solid's create effect, it works similarly. The effect determines when to rerun based on what reactive values you access inside it. So in this example, by accessing the values of size and color inside the effect, Svelte will automatically rerun the effect when those values change. And in case you do just want to read a value without subscribing to updates, we do provide an untrack function that lets you do that. Beyond the potentially visceral reaction to seeing words like state and effect in Svelte, the rest of what makes Svelte special is still intact. For instance, you interact with the raw state values instead of going through a setState function or object with a value property. And to understand why that's possible, we need to talk a little bit about signals. So Svelte is finally on the signals train. Today, it feels like every framework is either using signals or about to adopt signals, well, aside from React. But what does signals actually mean? Well, a deep dive on this is definitely outside the scope of this talk, and really our goal is that you should be able to use and learn Svelte 5 without ever learning what a signal actually is. But for the curious, a signal is an object that holds a value and that can also track when the value is read. So this means that when you update a signal's value, the signal knows all the other places that that value is used, and it can trigger updates in those places automatically. This lets you make very targeted, precise updates to your UI without a lot of wasted work. And in Svelte, we can even get more granular, tracking that, oh, you only access this object's property in this place, so we don't need to change if you update a different object's property. We can target it, for instance, just the name property on an object. But while signals are great for performance, interacting with them doesn't feel very Svelte-like. Part of what makes Svelte Svelte is this. It's the fact that you can take a reactive variable, and if you want to make changes to it, you don't have to use a set function or set a value property. You can just update the value like it's a normal JavaScript variable. But then how do we get signals to work? Remember, signals need to be able to track when a value is read and written to, and there's no way to do that with just a primitive number value in JavaScript. And this is why other frameworks have those set functions and value properties that we're trying to avoid. In Vue, when you declare a state variable with a number in it, you actually get an object back, not the number. Behind the scenes, Vue uses a proxy object that intercepts reads and writes to the value property and wires up the signal properly. And this is why in Solid, you get back two functions, one that you call to read and write the value, and that also gives Solid a way to put in the signal functionality that it needs. And there's nothing wrong with doing things this way. This is just a limitation of how JavaScript works, but it didn't feel right for Svelte. But to quote Rich Harris, when he discovered the core of Svelte 3, we don't need to be limited by what is possible at runtime in vanilla JavaScript, because we're a compiler. In Svelte, we start with what we want the authoring experience to be and use the compiler to make that possible at runtime. So in your Svelte component, you can write this, and Svelte will compile it to use signal methods under the hood. So we get the best of both worlds, an efficient, readable authoring experience that's easy for humans to write, that is then transformed into valid, optimized JavaScript for the browser to execute. Signals, but as an implementation detail. You can interact with state values like you're writing vanilla JavaScript and let Svelte's compiler handle the rest. And with Svelte 5's universal reactivity, that's true inside Svelte components as well as regular JavaScript files. All right, let's talk a little bit about performance. Svelte 4 was already fast, but Svelte 5 has made some even more significant gains in performance. A lot of that is thanks to Dominic Ganaway, creator of Inferno.js and former React team member, who joined the Svelte team last year and has been instrumental in eking out as much performance as possible. If you look at the JS framework benchmark, which tracks how long it takes various frameworks to perform different DOM updates, Svelte 5 is doing very well, way better than Svelte 4 did, and neck with Solid. And not only is Svelte 5 fast, but it also uses less memory and hydrates more quickly. There are lots of reasons why Svelte is faster now, many outside the scope of my expertise. But just to mention a couple, first, the compiler has been rewritten from the ground up with performance optimization in mind. And this involves things like making sure that the compiled JavaScript code Svelte outputs is super easy for browser engines to optimize. A lot of these may be micro-improvements, but micro-improvements definitely add up. And also, the reactivity being signal-based now, like I talked about, means that updates can be even more targeted and efficient than Svelte 4's compiler-based reactivity. Svelte is not the absolute fastest framework out there, but it is definitely almost blazingly fast. If you want to build a performant web app, Svelte is not going to require a lot of extra work from you. All right, let's talk a little bit more about bundle size. We made a couple trade-offs there. In Svelte 4, a Hello World app was only a few kilobytes, since Svelte had almost no runtime. However, because the reactivity was compiled into each component, as you added more components, the bundle size would increase at a steeper rate than frameworks with larger runtimes. With code splitting, most apps would not hit this inflection point. It would only show up in super large apps, but it was still something we wanted to address. But now, with Svelte 5, reactivity is now in the runtime, which means a slightly larger runtime, but smaller components. So a Hello World app will be slightly larger, but as you build bigger apps, you'll start to see the savings. Let's look at an example. An implementation of To-Do MVC, the famous To-Do app project used to demo different frameworks, is 7.2 kilobytes in Svelte 5 and 4.9 in Svelte 4. So Svelte 4 is obviously smaller. But let's say you have an app that's just 3 times the size of To-Do MVC. At that point, the Svelte 5 app is actually smaller than Svelte 4, 9.8 as opposed to 10.1, because the larger runtime means that not as much needs to be compiled into the component. And these savings will only increase the larger your app is. All right. I've tried to talk about as much of Svelte 5 as I can today, but there's still more stuff, and I only have 25 minutes, so I'm going to fall back to a listicle. You won't believe these other 9 features coming in Svelte 5. Snippets, event attributes derived by TypeScript and markup, reactive sets, bindable, deeply reactive objects, fine-grained reactivity, and the inspect rune. These are all things I don't have time to talk about right now, but if you check out the Svelte 5 docs right there, or come talk to me after, I'd be happy to share more about these with you. But something I find just as exciting as all the stuff we're adding is the stuff we're able to remove. These are all APIs that existed in Svelte 4 that no longer need to exist in Svelte 5, either because they've been replaced by something simpler, or the problem they solved is no longer a problem in the new design. This is the benefit of rethinking some of these APIs. Any design is going to accumulate awkward bits over time as you discover use cases that weren't considered originally, or rethink your priorities, or accept this PR that seemed like a good idea at the time. Designing from first principles means that you can create something that feels cohesive instead of tacked on. One last piece I want to touch on before closing is the migration story. This is an image I found when I searched for a ship of Theseus. I talked about a lot of changes today for how you write Svelte components. Importantly, while Svelte 5 is introducing new reactivity syntax with runes, you don't have to convert everything to use runes to start using Svelte 5. Instead, you can use your Svelte 4 components in Svelte 5 today, and they should work the same. Runes take effect on a per-component level, so you can have some components written using the old reactivity, some using the new, and they should work together. Being able to incrementally migrate to the new reactivity system is super important to us, since if we require everyone using Svelte today to do a massive Big Bang rewrite to start using Svelte 5, it would be very difficult for a lot of projects to adopt it. In addition to supporting Svelte 4 style components in Svelte 5, we'll also be supplying automated migration tooling to convert your components to runes. Because even though the old reactivity model is supported in Svelte 5, it will eventually be removed in Svelte 6 or Svelte 7 in favor of runes. While it's great for adoption to support both syntaxes simultaneously, it's not great for learning and understanding. If we decided to support both forever, we would essentially split the ecosystem, where some projects would use the old component syntax, some would use the new, and if you were learning Svelte today, you would have to decide which one you wanted to learn and use. In our mind, the benefits of runes are clear, and you should be using them eventually, but you don't need to adopt them all at once, and you don't need to do it all by hand. So that is a very brief overview of Svelte 5, the changes, the problems they solve, and the exciting improvements coming to Svelte. We talked a lot about how Svelte 5 compares to its predecessor, but its simpler mental model also means that this is a great place to start trying Svelte. If you're interested in learning more or giving it a go yourself, there are a few places you can go. For now, Svelte 5 is still in preview, though theoretically we're very close to actually getting a release out there. So if you go to svelte.dev, those docs are still for Svelte 4. If you want the docs for Svelte 5, as well as an interactive playground, you can go to svelte-5-preview.vercel.app and read the docs there. Once Svelte 5 is released, it will come with an interactive tutorial that will be the best way to learn Svelte 5. If you prefer to work locally, if you run npm create svelte in your terminal, that will start a new Svelte app and give you the option to install the Svelte 5 preview if you want to try out the new stuff. If you want to find me, head over to my website at jeffrich.net, where I have my blog, links to my various socials, and you can also find my slides and a full transcript of my talk there as well. All right, thank you so much for having me. Enjoy this picture of my cats, and enjoy the rest of the conference.
Yeah, give it up for Jeff. We waited the whole time for the picture of the cats. All right, so we do have a break right now. So come back at 11:15 sharp, or go to the workshop at 10:30. All right, hands in. 3, 2, 1, break! It's kind of a long walk. Yeah, good job.
you can look at the screen now. Do you want to test those mics, John?
Bit of your first part of your presentation.
Okay, sure. Hey, I'm Kristen. We're checking the sound. Is this a good volume?
Very good. Let's do number 3 now.
All right. Hi there. I'm Molly Jean Bennett. Super happy to be here.
Excellent. Thank you so much.
Welcome back from the break. Yeah, let's get it going. Nice. Yes, we have our next speaker. Let's just wait for the video to play. So next up, we have Kristen Thayer, and she chose to be introduced in Regency era. Her Majesty, Queen of meeting impossible deadlines and the talk of the town. She's the engineering manager at Seesaw Learning and has promenaded to CascadiaJS to talk about how to manage up. True queen behavior. And in the most extraordinary display of skill that can impress the whole, she can manage to change a poopy diaper during a business meeting. Long may she reign. It's Kristen Thayer.
Slides? All right, there we go. Awesome. So I'm Kristen Thayer. It's great to be here. I'm an engineering manager, and I want to talk about debugging your manager relationship, which sometimes we call that managing up. And there are so many great talks and ideas here, and I know from experience, sometimes you go back from a conference and you're like, I want to try everything, and your manager does not get the vibes. So that's where managing up comes in, and this talk is about how to get your manager on your side when something matters to you. So as a manager and as everybody's manager friend, I get a lot of questions that fall into this bucket. I want something from my manager, but I don't know how to ask. So we're going to talk about some tips and tricks. We're first going to talk a little bit about where your manager is coming from, their perspective, and then we're going to go over 3 tips: asking clearly for what you want, framing your issues in a way that's more likely to get a yes, and debugging a no to bring clarity and get buy-in for the next time. So let's look a little at your manager's perspective. A little context to start off with, might seem obvious, but your manager is a human. We have good days, we have bad days, sometimes we forget things or miss context or have too many meetings. That's just real life. Number 2, your manager's probably on your side. Most of us do get into management because we care about people. Whoops. There we go. We care about people as well as code, and we are genuinely rooting for our employees to succeed. Okay. Number 3, we might have some additional context on other things that are going on your team, on your org, in the business, sometimes the history of the code base. So that might be influencing how people are responding to you. And then lastly, sadly, your manager might not have all the training and the practice that they wish they had. It's really common in tech to promote high-performing ICs into management with little to no training. And so sometimes your manager might be still figuring out the ropes. All right, so we're going to go into tip number 1, know what you want, ask for it clearly. Again, remember your manager's context. Sometimes we miss some things or we have a lot of meetings, so it helps to be really clear on what you're asking and specifically what you want your manager to go do as a result of your conversation. We love to go do things. So for example, one of the most common sets of questions I get is understanding rewards and promotions and things like that. But folks can get really afraid to ask about this, and so they can turn a little bit vague. So let's actually look at that as an example. So example number 1, I want a promotion. But when people are afraid to ask, the way that this comes out the most is like this: I want to grow. And like, that's cool, that's a start. But for your manager, they're going to be like, well, grow at what? So usually round 2 sounds something like this: I want to grow in my career. Which might feel very forward, but from your manager's side, they're like, okay, what do you want? Soft skills, cross-team communication? Do you want to be on a different track? PM, TPM, what do you want? So you can be really bold and really specific and ask for what you want. So here's one example. Hey, I want to know that I'm on track for my next promotion. I'd love to work through some specifics of where I should focus my efforts and what I should ignore over the next 3 to 6 months. Very, very specific. And then boss level, you can add on something like, can we turn this conversation into a document and check back in on a monthly basis? Managers love that. So be really specific in what you're asking for. All right, number 2, framing your issue to create a win-win. Again, your manager's perspective. There could be a lot of things going on. There could be some politics, people who want things or don't want things. So it's important to think about, from your manager's perspective, how is this ask going to come across? And there are some strategies for that. You can think defensively. Why might your manager or others say no to this? You can think offensively. Why is it good for your manager or good for others to say yes to this? And you can think collaboratively. Can you reframe this issue as a problem that you're both solving together? Or you can do all of them together for the win. All right, so another example. Really, really common. Maybe you want some more focus time. You want to skip this meeting today. So we're going to start off with most people's gut reaction to this. You might call this the truthful response. I'm going to call it the uncollaborative response. I hate this meeting, and I want to skip it. I mean, points for honesty. That's a start. But from your manager's perspective, this isn't going to get a yes. Let's look at some ways to get a yes. So defensively, what is your manager worried about? Hey, I want to skip this meeting, and I know you're probably worried that I'll miss context. So I want to let you know I will definitely check in on the notes later. That's a little better. All right, let's think offensively. Why is this good for your manager? Hey, I think I can finish this ticket if I can get 1 more hour added to my focus time, which is right next to our meeting. What if I skipped it just this once? Again, a little better. All right, then there's collaboratively. Why is this a we problem? I know we're headed for a big launch. I want to make sure we have time to get everything done. Some of these meetings make that tough. Is there a way we could solve this together? And then lastly, everything together all at once. Hey, I know we're heading for a big launch, and staying on track or ahead of schedule is really important to all of us. What if I skip this meeting just this week to help us stay on track? I'll definitely make sure to read the notes so I don't miss anything. And putting all those things together, much more likely to get a yes. All right, so sometimes you do your best, you ask clearly, you think defensively and offensively, collaboratively, and you still get a no. So now what? And the good news is, remember your manager context, your manager might be on your side, but just tired or they missed something. So this is where, as a developer, you get to put your debugging skills to work. You can drop a breakpoint in that interaction, examine where and why it's going wrong, and change your inputs to get different outputs for the next time. So some of my favorite debugging questions, you can literally use them verbatim. I promise these work. You can say things like, is there any wiggle room? Is there anything that would turn that no into a yes? I'd love to understand more. Is there more context you can share on that? I'd love to get your take on this. And I'd love to work together to figure out something, maybe not my original proposal, but something related. So again, everything's better with examples. We'll do one more. Let's say you go back from this conference, you want to integrate ChatGPT into your product. You gave your manager a diagram of how it's all going to work and how it'll still fit into the schedule, and your manager comes back with, yeah, I don't think that's going to happen. So this is where we dig in. How do you figure out what's going on and why you got to know so that you're able to turn it around? Again, first response, a lot of people just kind of like, okay. Silence isn't going to help you. You're not getting any new information with that. Second attempt, people will try things like, but it's a good idea. And like, I'll be honest, it probably is a good idea, but saying that is just going to make you come across as defensive. So how do you get this to work? You could say something like, I'm curious to understand why. Is this something you've considered before? By hypothesizing, you're opening up for alternative hypotheses, which gives you more information from your manager's context. Even better, you could say something like, well, I imagine there are a number of reasons you're saying no. I don't want to be rude or argumentative, but would you mind helping me understand just a little bit more? And by giving a more open-ended question, that invites your manager to share a lot of their context. And you could even add on something after that. Is there any wiggle room? Is there any opportunity to turn that no into a maybe? And by asking those kinds of questions, you can get a lot more context on why you got a no, which means that you know what the real questions are to turn around so that you can get a yes this time or at the next time. And remember also, these conversations are an opportunity to show your manager that you want to be a partner with them, which opens doors for future collaboration. All right, so let's review. We had 3 tips, 3 examples. So just remember, your manager is a human who sometimes makes mistakes, who sometimes has more context on the team, the org, the business, but they're probably rooting for you and want you to succeed. And when you bring something to your manager, ask for what you want clearly, frame your issue as a win-win by thinking from your manager's perspective, and debug a no for better context and collaboration on future asks. That's it. Good luck. I hope you have an opportunity to work back with your manager on something from this conference, and I hope you get a yes. Thanks so much.
Wow, so amazing. Okay, next up, we have our next speaker, Molly Jean Bennett. As you can see, I don't really know her. But seriously, wait, Molly, where do you work again?
Girl therapy?
No, wait, me too. Yeah, Molly is one of my favorite coworkers. Don't tell my manager. But I just love Molly so much. She's such a creative soul. I mean, look at the top that she made herself. Super cool, right? Yay! And my favorite thing about Molly is that she just chooses to have fun. Everything that she does. I mean, look at this. This is how she manually QAs the video conferencing feature. But Molly is just a joy to have around, and I absolutely adore her. So you better listen to her talk, or else I will fight you. So give it up for Molly Jean Bennett.
Hey, everybody. Just getting situated here. Oh. Just bear with me one moment. All right, there we go. Yay! All right. Hey, everybody. Let me just see if I can get the clicker working also. Oh, beautiful. I'm so glad to be here. So not long after I learned to code, I got interested in making my own clothes. So I learned to sew and dabbled in some other fiber crafts. And here I am in the crooked yellow shirt, which is the very first one I made. And learning these skills kind of broke my brain open. Learning to code made me confront everything I believed about the limitations of my intelligence. And sewing taught me this whole new spatial language. And I've thought a lot about how differently these two skill sets are valued and who tends to do them around the world. So 60 to 80% of textile workers around the world are women, and they make, on average, 2 to 5 times less than the amount that would be needed for like a minimum livable wage in any given country. Meanwhile, we software engineers tend to be really highly paid, and about 8% globally of us are women, though that's higher in the US, about 28%. And coding and clothing production aren't just connected in my brain, where setting a sleeve is hard in the way that understanding a closure in JavaScript is hard. These fields have been interwoven, if you will, since the very beginning. So we have a lot of folks talking about AI tools, and my own experience of using GitHub Copilot is kind of like Josh said yesterday. It's like amazing at the things it's great at, including unit tests. So this is me writing a simple unit test for a functional React component. And as you can see, it's taking Copilot like less than a second to suggest something that, while not a huge lift, might have taken me a few minutes to write. So let's, and I'm sorry, Tyler, this is like a really low quality GIF, and I did have other options, I now know. So let's talk about how this is similar to this. So this is a Cartwright power loom, and it is, like Copilot, among a set of innovations that characterized a period of rapid automation of human labor. At the end of the 18th century, the wool trade employed 10% of Britain's population, and weavers in particular were the largest class of laborer. Now, prior to industrialization, people worked in their homes, in small shops, among their family members, and most weavers could make an excellent living wage working less than 30 hours a week. Now, cloth makers often improved the tools of their trade, making things more precise, faster, more efficient, like with the flying shuttle and the spinning jenny, and they all have like amazing names like this. And by the late 1700s, though, things were really changing. These technologies were being supercharged by the addition of hydro and steam power. So Richard Arkwright was an inventor who hooked up the spinning jenny to a giant water wheel, so that rather than employing the teams of women who had traditionally spun wool or cotton into yarn, he could do this around the clock in a factory staffed by totally unskilled children as young as 6, and most of them were orphans. Weaving, though, as opposed to spinning, was long thought to be way too complicated to ever be fully mechanized. But in the 1880s, a poet and clergyman named Edmund Cartwright visited Arkwright's factory, and he left determined to invent a machine that would revolutionize weaving in the same way. By 1785, he had patented a really horrible first version of this, but he and others continued to really rapidly iterate on it and improve on it until it was actually pretty good. And 25 years later, the cloth trades were being really disrupted by these new factories and sets of innovations. So also Britain was in an economic depression due to the Napoleonic Wars and a few years of bad harvests. And many workers in the countryside were facing starvation. Textile workers from the old cottage system were having a lot of trouble finding work as the market was just flooded with these cheap, often inferior fabric yardage and knitted stockings that were coming out of the factories. And they'd already made appeals to Parliament to help blunt the effects of factorization. They asked for retraining programs or taxation on technologies that eliminated skilled jobs, which are ideas we're still discussing today, by the way. But they hadn't seen any success in getting this. So enter the Luddites. If you've heard the term Luddite, it's probably been used as a pejorative, or maybe someone self-identifies that way, but it's very much against technology, against progress, fearing the future. I'd argue this is a pretty classic case of history being told by the winners, though, because the Luddite uprising was a labor movement, and it was comprised of textile workers and their allies. It began in 1811 in Nottingham, England, and it ended up spreading throughout the entire country. Working in autonomous, really tightly coordinated cells, the Luddites would break into factories and smash stocking frames and power looms with these giant sledgehammers. And they did this in this really targeted way. They would leave some machines untouched, but those that they deemed hurtful to commonality, those are the ones they crushed. So they also loved theatrics. Like they wore goatskin masks on raids or often would dress in drag. And the word Luddite comes from Ned Ludd, who was a probably fictional apprentice who was admonished by his master for knitting too loosely on a stocking frame. And then in retaliation, he smashed the master's frame. So this became kind of like the folk hero of the Luddite movement. And they would sign their list of demands and missives with the name General Ludd. And initially, they were really successful. They got local victories, like getting factory owners to agree to price thresholds for certain goods. And so they had this huge momentum initially. And it was this really big movement. In 1811 and 1812, they smashed thousands of machines. It was really broadly popular and hard to quash. The Crown deployed masses of troops, and the troops found a really hard time to even infiltrate the Luddites because they were in such tight, socially connected cells. Ultimately, though, 40 to 50 Luddites were killed either by hired factory guards or they were hanged by the Crown. Basically, they made machine breaking a capital offense. And the Luddites killed one person. Several Luddites assassinated a factory owner. And in the trial of these assassins, the major narrative that we know today of the Luddites was formed. The ruling class formed this narrative that Luddites were this brutish, angry, uneducated mob that was being inspired by infiltrators to go crazy and smash things. The public execution that followed that trial really marked the end of major Luddite activity in England, though smaller acts of disobedience continued for quite a while. And so broadly, the industrialists won that chapter. And in the wake of this, our own field of computing really emerged. Let's talk about another loom. This is a really cool loom. This is the Jacquard loom. And this picture, this was a silk weaving that was actually made on a Jacquard loom. And a Jacquard loom is for weaving intricate patterns into fabrics. And this is incredibly labor-intensive, expensive craft. And in 1804, Joseph Marie Jacquard patented this loom that used the punch card technology to basically determine a binary for a pattern. So there's a punch card and the weft thread. If there's a hole there, it's going to pass through and create the pattern. If there's not a hole, it doesn't pass through. So that's where we get really the inspiration for binary. And this was used by Charles Babbage and Ada Lovelace when they built the analytical engine, which is considered to be the predecessor to the modern computer. So they directly use that punch card technology to express mathematical programs. And I feel like the way that I've often read about Babbage and Lovelace and the project of the analytical engine is as this kind of pure mathematical inquiry and innovation. But I feel like we don't talk a lot about what Babbage was actually trying to do, which was that he imagined computerizing entire factory systems so that there would be no humans in sight. And he wrote this whole book about it. And a totally automated process with no people is something that we're still chasing. Amazon has announced, but not yet achieved, totally robot-staffed fulfillment centers. Then there was that recent controversy of the AI-powered store, which ended up not being AI at all, but actually a bunch of cameras and low-paid workers watching through them to determine what people were purchasing. So where does that leave us? When I think about the Luddites and the factory owners and Babbage and Lovelace, it can be kind of hard to thread the needle for the metaphor of my own role. Am I building the power loom or being replaced by it or creating a whole new category of technology? And the answer is probably a little bit of all of these. Whenever Copilot writes a unit test really quickly or does something awesome, it delights me, but it also sends this little shiver of fear down my spine. Am I watching my own replacement? And I don't know the answer to that question, but I think it would be a good idea to remember a few lessons from the Luddites. 1, don't assume inevitability. In the time of the Luddites, the ideas of modern capitalism were very new, and no one knew exactly how it would play out. They defended their way of life as if it was fully possible to retain their power and autonomy as artisans. And while they weren't ultimately successful in stemming the tide of factorization, they slowed it down and they created a blueprint for later labor movements. So I don't know the future either. And assuming certain outcomes can make them self-fulfilling prophecies. It dulls curiosity and creative thinking, which leads me to 2. Protect your craft. And I think we have a lot of other people talking about this as well. As I mentioned, I love a good Copilot unit test. But I try to be mindful of when I'm using AI tools to speed up a familiar task and when it's preventing me from learning something new. Like right now, I'm trying to get more comfortable on the back end, and Copilot is great at suggesting what might come next in a line of Python, but that doesn't mean that I'm going to understand it. So finally, ask who benefits. The history of industrialization teaches us that automation doesn't necessarily eliminate labor so much as it marginalizes it. Whether that's the orphans in Arkwright's factory or very low-paid workers working on the clothes you wear in Bangladesh. And this marginalization isn't as visible today as it was in the 1810s, when people could see the factory being built on the edge of town and watch the air darkening with coal smoke. We don't always see our global supply chains, which can feel really vague, and we don't necessarily see the data centers that are running carbon-intensive machine learning processes all day. But that doesn't mean we shouldn't think about them. As an individual contributor, it can feel easier to just kind of shrug my shoulders and say, like, I don't control what I build. It's not up to me. But I try to stay curious and skeptical when it's warranted. Should this feature really incorporate AI? Is this good for our users, or is this a shiny toy for our shareholders? I can create friction by asking these questions, by talking to my coworkers. I don't have a sledgehammer, but I have a brain and I have a voice. Thanks so much.
Our next speaker is Jerome Woody. We'd like to thank him for taking his time to travel such great distance from his home a block away from here to the conference center. And yeah, while all of you are getting bagels, he just woke up and came straight to the stage. He's a senior front-end engineer for Discogs, and he's here. Oh yeah, we also have one person who works there. And he's here to share with you about Vaporwave. Oh, I mean LLM chats. Vaporwave is for after party. Yeah, it's Jerome Woody.
Sorry, I'm trying to get this to work. It was working so fine like a half hour ago. Something happened. Yeah, thank you so much. So yes, my name is Jerome Woody. I am a senior front-end developer at Discogs, the best music site on the planet. But I am not here to talk about music. Maybe next year, if you guys are good. What I am here to talk about is television shows, including my favorite show of the 2010s, Westworld. Yes, thank you. Oh man, can we just beg for a new season? Somewhere. Just saying. So, in Westworld, one of the concepts in the show is what's known as analysis mode, right? And in the show, the hosts, the synthetic people who populate the futuristic theme park, can go into what's known as analysis mode, a state where the host can sort of disassociate themselves from their personas and go into a state of deep introspection, right? And it's from this state that park employees can query the host and get a picture of what their thinking processes are, right? So, like many of you in the audience, large language models have been creeping into my workflow since late 2022, right? And today it's become one of the premier or one of the top ways that I analyze and transform information. Now, I'm a web developer by trade, so most of the time I'm using large language models and chatbots to generate code or debug code for whatever project I'm working on, right? And because it is code, if I want to test it out, I can always throw it into an interpreter or a compiler, run it. And if it runs, and it runs as expected, great. But if it doesn't run the way I want it to run, I would either have to reevaluate the way I interact with the chatbot or have to rethink my whole methodology entirely, right? However, I also use chatbots to ask questions about various subjects outside the realm of computers, right? Sometimes I want to know about an argument of something or get some facts about a concept that I'm not familiar with. These types of outputs you cannot easily put into a logic checker. So it is at this part of my interaction with large language models that I wonder, can I have my own analysis mode? And I think I found a solution to this. And the solution comes from a very personal place in my life, my library science education. Meet Dr. Michael Eisenberg. Mike was a professor at Syracuse University, and he, along with a librarian called Bob Berkowitz, created what's known as the Big Six process model for information-based problem solving back in good old 1988. This is an information literacy model based to teach anyone how to do effective research. I met Mike when I was a student at Syracuse, go Cuse, back in the late 90s, and he went on to become the founding dean of the information school at the University of Washington. Go Dogs. All right, so what you're seeing now is the Big Six. And the Big Six is follows, and I'm gonna have to look this up because it's a lot. Task definition, define the problem and identify information need. Information seeking strategies, determine all possible sources and select the best ones. Location and access, find the sources of information within them. Use of information, read, listen, view, and extract relevant information from sources. Synthesis, organize information into multiple sources to create a product or answer. And finally, evaluation. Judge the product's effectiveness and the process's efficacy. Anyone can use these steps to do effective research. So I thought, what would happen if these steps were done by a chatbot? Went back, there we go. Okay. The Big Six process model is one of the most popular tools for teaching information literacy worldwide, and it has been for decades. It has been taught in classrooms and in libraries throughout the world. Many papers and explainers have been written about it, with most available on the open web, which was, by many large language models, trained on, right? Because of this training, the concept of the Big Six is included in their knowledge base and can be inferred upon by just using a text prompt. Through experimentation, I found that combining a reference and just a reference to the Big Six with a task and a text prompt dramatically changes the output and organizes it based on the Big Six model. This can be done in two ways. In the initial prompt, which I call blueprinting, and as a follow-up prompt, which I call reflective analysis. Although reflective analysis comes closest to what I was thinking while watching Westworld, I believe that it's through blueprinting that using the Big Six can lead to higher quality output and possibly fewer hallucinations. All right, so let's see what I'm talking about here. Okay. In this video, you see me applying blueprinting to a prompt in ChatGPT. The prompt's main task is to have ChatGPT generate an explanation for the factors that led to the 100 Years' War. Notice that I only had to refer to the big six in order for the output to be organized into the 6 steps. I call this technique blueprinting because, along with the answer, the LLM generates a blueprint to help users find the answers themselves. The LLM's answers are still there, spread out in step 4 and step 5 of the process. This technique does not just apply to ChatGPT. Any LLM using a text prompt interface can have this technique applied. Here you see me applying the blueprint technique to Anthropic's Claude chatbot. I asked it to give me a history of the neighborhood that we are all currently in, First Hill. Whoop. That one got excited. Here I show an example of reflective analysis using Gemini. Oh, Gemini. First, I use a traditional zero-shot prompt asking for an explanation over the ontological debate regarding what came first, process or entity. And we got information science people here. I know you guys are vibrating right now, because that is heavy stuff, right? Once Gemini creates its output, I give it a follow-up prompt, asking it to consider the last output using the Big Six model. It then takes its previous output and breaks it up into the 6 steps. It's like giving a student a homework assignment. So, how is any of this possible, right? I have a hypothesis, and I hypothesize that by having to process a model like the Big Six, contextually, LLMs are forced to be less creative because not only would it have to infer the main task in the text prompt, but also token weight spaces related to quality control concepts, like breaking down tasks, considering sources, and evaluating its own output. So I have a name for this hypothesis. I'm calling it the Ariadne hypothesis, after the Greek goddess of mazes and labyrinths. But there's also a character in the movie Inception, played by Elliot Page, who's also called Ariadne. I don't know if anyone noticed that. But yeah, that's true. They named her after the goddess of mazes, right? Like that character who builds mazes to control a target's projections, blueprinting creates a maze of context in which to control hallucinations. I sincerely stress this. This is just a hypothesis. It has yet to be scientifically proven. It's just a hypothesis. Research related to using prompt-based techniques to clamp down on hallucinations has been done. Researchers at Tencent have found that if you prompt an LLM to give both the right and wrong answer to a question, a question to the output, which is also called contrast prompting, the chances that the right answer will be right increases significantly. Researchers have also observed increased performance in symbolic reasoning and arithmetic. Although this is not directly linked to what I'm proposing, the research on contrast prompting seems to prove that using reflective-based contexting can improve output quality. All right. To wrap up, I believe that everyday users, including everyone in this audience, using LLM chatbots can use the Big Six in the techniques that I have described to simply, in a simple way, to imbue some level of quality control and transparency into your text prompts. Blueprinting may or may not lead to less erroneous output. I don't know. I really don't know. It's just a hypothesis. But at least you will have a printable blueprint to use to determine that yourself. To academics in the audience, and I hope there's a few, I urge you to look into my hypothesis and determine if I'm onto anything here. To AI developers, which I'm sure are in the audience, the Big Six can be something that can help train models to reason better, or as a structural mechanism that you can plug into the model's input layer to help guide token computation. Either way, I firmly believe the key to making LLMs generate more accurate output is by serving it prompts with a side of library science. Thank you. And on the slide here, on the left, is a link to the actual 10-cent paper about contrast prompting. And on the right is a GPT that I have configured with Big Six context built into it. So you don't even have to use the substring, use Big Six, just ask it any question. It will know to use that Big Six model in its output. So go ahead, go on there. Obviously, ChatGPT Plus is required, but as soon as other type systems come out, I'll make versions of that. I know like Gemini's coming out with a GEMS system, so I'll probably do that as well. But for now, there it is, and that's my presentation. So thank you so much.
Did everyone enjoy the last 3 talks? It's more humanity focused, which is awesome, right? Yeah. I mean, what's a AI conference without talking a little bit about humans, right? So next up, we are going to move on to the startup fair. I'm about to bring up Jim, who is here, and he will be talking about how the startup fair is going to go.
Hello, Cascadia. Hello, everybody. I may have met you during the conference. My name is Jim Liu. I'm one of the volunteer organizers who put together the startup fair. The startup fair's purpose is to showcase startups and the products that they build for this community. And we have this event tonight, concurrent with the closing party at 6:30. And you can talk to the startups. And right at this moment, right before our lunch, I want to give the opportunity for the founders to do an elevator pitch. So Javier, Adam, if you are in the crowd, feel free to step on the page. Oh, there's Javier. And I will give the mic to Kyle, and you have 90 seconds.
5 minutes, you said? Well, hello, everybody. My name is Kyle Weedman, and I'm with a company called HookDeck. And the legend has it is that our CEO, Alex Bouchard, built HookDeck in the back of his camper van on a ski trip because he was sick of dealing with Shopify webhooks. If you've ever had to reliably ingest webhooks at scale, you've probably spent a lot of time gluing various technologies together like API gateways, Kafka, RabbitMQ, or SQS. Not only have you likely had reliability issues, but you've probably struggled to track down business critical failures when they happen. Fast forward 4 years, and HookDeck's a lot more than just a webhook ingestion infrastructure. It's what we call the event gateway. Think of the event gateway like an API gateway plus a queue plus a message router. It's a developer platform that allows engineering teams to receive, process, and deliver messages across your event-driven architecture. It supports your full software development process from CLI with ngrok-like replacement and development, all the way to logging and observability tooling. Lots of big words. So common use cases might be ingesting webhooks from services like Shopify, Stripe, or Twilio, sending webhooks out to customer endpoints, or receiving telemetry events from IoT devices. So with over 20,000 developers on the platform, HookDeck is trusted by engineering teams of all sizes, from side projects to startups to some of the biggest Fortune 500 companies. Also, it's free up to 10,000 events per month, ... in between free. So we'd love for you to give it a try and give us your feedback. Yeah, like Jim said, we'll be down at the startup fair at 6:30, so come by, give us a chat. We'll give you a demo, and you can email me directly. My email is kyle@hookdeck.com. Thank you.
Awesome, and also huge shout out to the whole CascadiaJS team and all the speakers and sponsors that are like making this amazing event. Like seriously, couldn't do it without you guys. I don't have nearly as cool of a background story as HookDeck does, but I'm Alan Deutsch, and I am building a tool to make docs better. I used to run gaming docs at Microsoft, and one of the challenges that I had was that it's really hard to get useful feedback on your docs. And as we heard from Josh yesterday, it's really important to start with the docs and give feedback on them if they're not solving your problems. But the reality is that as a developer, there's all sorts of reasons why you might end up not doing things the way you should. You have other deadlines, you've got other work to do, or maybe there's just too much work involved in doing things the right way. And so, unfortunately, when that happens for a developer who's reading your docs, you miss out on that super useful feedback. And those gold nuggets are really what you need in order to make sure you're serving your customers well. And if you don't do it, they'll end up looking for other solutions or churning and finding something else that does have better documentation so they can actually figure out how to use it and get back to whatever it is that their product does. And so DocDuck helps with this by giving you a really easy to use widget in your docs where users can provide feedback on any part of the documentation and then provides you on the back end an easy to use management API for handling all of the feedback that comes in, sort of like a task management tool. And so you can get all of the feedback that you need from your developers and then very easily action on it. And so if you want to find out more about how you can improve your docs with DocDuck, you can come visit me at the startup fair. It'll be the one with a yellow rubber duck. Or you can reach out to me on Twitter or go to docduck.dev to sign up for launch notification. Thanks.
Hi there, I'm Javier. I'm one of the founders at HAL9, and we're a company that can help web developers build chatbots with generative AI. So let me just quiz you, quick question. Who in here wants to be involved in projects that use web applications and generative AI? Is it like half hands? Yeah, there's a good amount, like maybe 20%, 30%. So yeah, what we can do, and as a follow-up with this conference, is we have a web page, hal9.ai, where you can basically create a chatbot in like literally 5 minutes and then embed it in your website. What is really cool is that then you can show it to your team and be like, hey, why don't we have a chatbot in our website? Like, that's something that we should have. Now, the way that our platform is different is we're the only ones that allow you to modify the backend code. So once you get buy-in from your team and they're like, oh yeah, that sounds like a great idea, you can look at the code that is running the chatbot. So like you can change the Python code with LangChain and the like. We're adding support for JavaScript, so that's kind of like your path to working on those types of projects, if that's interesting. And yeah, we're going to be on the startup fair, so feel free to stop by and we can chat more about it. Thank you.
All right, thank you, Cascadia. This is our introduction to our startup fair tonight. See you at 6:30.
Yeah. Give it up for the startup fair. Cool. So now it is time for lunch. We got a bunch of talks that came with a punch, and now it's time for lunch. What did I say about Dr. Seuss? So come back at 2 or go to the workshop also at 2. So the food should be downstairs at 12:15. Enjoy your lunch. Bye. Yeah.
Thanks, everybody.
Thank you.
y'all.
Have a good one.
Yeah, you too. See you around.
Yeah, lunchtime.
Charge your.
Thank you.
And I'm gonna wrap the mic cable up so you.
Go ahead and turn that mic on too. Hear what that sounds like. Your mic is. Oh, mic 3. Mic 3. There we go. Go ahead. Yeah, why don't you just sit?
I'm going to talk about React 19 and I'm going to crack some jokes so y'all can laugh.
That's great. Everybody remember to laugh. What's the question?
How's the font size?
I can read it and I don't understand anything.
Perfect.
So that's good. Does everybody agree? Yeah.
Cool. Thank you. All right, all good then.
I am handsome. 1, 2. I am handsome. I am handsome. I am handsome. I am handsome. Sounds good.
But continue for a little bit longer, would you?
I am handsome. I am handsome. He is handsome. They are handsome. You are all beautiful. Yeah? Okay.
Okay, thank you.
We good?
We're good.
I know, right? Okay.
John, is this the last check right here for now?
Do you know a dev joke? Then send it as a pull request. Okay, I know some of you are like, okay, I didn't come here for jokes. Tell me the React 19 shit. So let's talk about what's new in React 19. So React 19 features or React 19 updates can be broadly divided into new features, new hooks, and new APIs. Let's first talk about the React 19 features. I think React 19 has a big focus on improving how forms are supported, and one of the hook or features that enables that is React Actions. React Actions makes it easier to handle forms, and here's an example. You may have heard of React Actions in the server context. It takes its inspiration from Remix, actually. So here's an example of how we handle input fields today. So there's an input field on the screen right now, and we usually have like a set state that we assign whenever there's an on change, and that's how we store whatever was updated in the input. And then if you want to submit this is a div right now, but this could be a form as well with multiple fields. If you want to submit this form, we'll have a handle submit function, and then once we handle submit, we'll take everything that was submitted in the state and handle it. And then if we want to show a loader, we also do that typically in the handle submit function, which is where we call our API. And the way we do that is we'll first set our is pending to false or to true so that we can show a loader, call an API. Once you've done calling an API, we'll set the is pending to false, and that means our loader can go away. And this is how we do kind of loading states right now and handle forms right now. Now, with React 19, we can actually have an async function within start transition itself. Start transition was introduced in React 18. So here in handle submit, I'm using a start transition. There's an async function within it, and that's where I'm going to handle. Now, because start transition is used to manage urgent updates, it also gives us back an is pending variable. And that is the variable that gets automatically updated whenever an API is being called and set to true. And then once the API is called and the function is done, it is set to false. So this is the variable that we can use to show a loader. And that is an action. So action is basically an asynchronous function that we can use. That's all. That's action. Functions that we can use to do async transitions. They're also supported on the server. And I talked about how React Actions helps to give better support for forms. And this is how we do it. You might have seen this kind of syntax in PHP. It looks pretty familiar. But now, instead of having to submit a form by using a handle submit on a button, we can just tie a form with an action using action function. This action function comes from a hook called useFormStatus, and the signature looks like this. We'll look at this in a detail in 1 second, and we'll also look at some code to figure out what it is. But basically, what you need to look at here is there is a pending variable, and there is a data variable, and an action variable that is super helpful for getting the data that was submitted to the form, taking it out, and using it in our state, and using the action, which is used to submit the data. So that was React Actions. In short, React Actions are super helpful for submitting forms and provides a better support for submitting forms in React 19. The next feature is React Compiler, which I am actually super excited about because with React Compiler, you do not need to use memo and use callback anymore. And I know, so exciting. And use memo and use callback actually is a huge pain because if you know about optimizing React applications, you know that use memo and use callback are super important. And oftentimes, you have to find code something like this and add it around use callback. It's usually a manual process. You have to first figure out which function is slow, figure out where the performance is slow, and then add wrappers around it, optimize your functions, and so on. But with React Compiler, there's auto-memoization, which means that React Compiler figures out the places in your code which are slow and optimizes the code so you don't have to use memo and use callback anymore. One interesting thing that if your code is really well memoized with use memo and use callback and you're doing a great job, you may not see any performance optimizations, but I've seen that oftentimes whenever I have use memo and use callback, I often forget to put it at places where I need to. And so React compiler can do a pretty good job at that. So the way it optimizes it, it reduces re-renders. And let's take a look at exactly how it does that. There are two things that it performs, that it optimizes. The first is it skips re-rendering of children when parent updates. And you might have seen this, that in React, anytime a parent's props changes, all of its children update. And here is an example. So here's a component. There's a friends at the top. Friends could be an array. And you'll notice here that there is a map, which maps over friends and renders a component. And then there's a message button, which has nothing to do with friends. However, anytime friends updates, all of these components update. Right now, we have 2 components, but you can imagine this could have multiple components. And this can lead to a lot of re-renders. So React compiler optimizes this by understanding that message button doesn't depend on friends. So it doesn't need to re-render that. And also, the value that comes back from friends list card can be reused if needed if friend hasn't changed. So the second thing it does is it skips expensive calculations. And exactly how it does is it understands the knowledge of the JavaScript rules and rules of React to figure out where we can skip expensive calculations. One caveat, though, is only memoizes React components and hooks and not every function, which basically looks like this. For example, if you have a really expensive function at the top, it won't memorize that specific function because it's not within a hook and it's not within a React component. However, if you're calling this function within a component, the value of that function is still memoized. So you still get some benefit. The React compiler looks like this. This is the React compiler playground. So if you want to figure out which code has been optimized, you can take a look at React compiler playground. And why this is helpful is because I mentioned that it follows the rules of React. And let's say that some of your code is breaking rules of React, you don't know, you're not aware of it. You can look at React compiler playground to figure out which components are breaking rules of React. And the way to figure that out is on the left side is the component, and on the right side, you'll see a $sign. Hopefully that's legible in the back. And you'll see a little $sign. So the $sign basically represents that that code has been optimized by a React compiler. So in short, no more use memo and use callback. But what if you're a big fan of use memo and use callback? Don't use it. React compiler is actually available as an ESLint plugin, so you can just npm install ESLint plugin, and it looks like this. This one really cool thing about React compiler is that there's a working group with it. I was part of React 18's working group, and I had an amazing experience learning about React 18. So if you're interested in React compiler, I highly recommend it. Great place to ask questions and have discussions. So that was React compiler. Now let's take a look at some of the new hooks that React 19 introduces. The first hook is use form status. We kind of briefly looked at it, but let's understand what it does. It actually gives you the info of the last form submission. So here's the function signature. It gives you back pending, data, method, and action. And pending is set to true or false depending on if the form is being submitted. Data is a form data object. Now here's a little catch. It is a form data object. It's not a JavaScript plain object. So if you're used to doing like data.name being the property, you can't do that anymore because it's a form data object. So you have to do data.get and then the property name. This can kind of lead to some errors, so be careful of that. Method is get or post, whichever you want to use. And action is the function action that we can use by creating another action, which I'll show you in a minute. One catch, though, is you can only use it inside a form's child. So what does that mean? So for example, you have a form here, and I want to show a pending loader state or something. I cannot use it before the form. I have to use it inside the form. So here you'll see I created a submit component itself, and within the submit itself, you can use the pending state from use form status. So you cannot use it above the form. It has to be a child component. The next hook that we're going to take a look at is use action state, which updates the state based on an action. And this is super handy as well because it gives you back the state that was modified after the form was submitted and the form action. And the function that it accepts is the function to be called when the form is submitted. This is kind of like your action. So here's an example, and this is the form action that comes back from this hook is the action that you will use to wire up your form with. And then we also have use optimistic, which is really cool because it can be used to optimistically update the UI. And React now gives it directly to you. The function signature looks like this, pretty straightforward, optimistic state and add optimistic. React also introduces a new API. Now, this looks like a hook, but it's actually an API. Use is actually an API that can be used to read resources. And when I say resources, I mean context and promise. Let's take a look at context. So use can be used to read context like this. You might be familiar with use context hook, which also does the same function. The main difference is that use context is a hook, and this is a API. So that basically means it doesn't follow the rules of hooks. So you can have it. You don't need to have it at the top of your component. You can have it anywhere in your component. One caveat, though, that it does not support. Oh, wait. Also, use can be used to read promises as well. So something like this. So you have a comments promise. You can use as well. One caveat, though, is that use is not supported for render promises. So this comments promise needs to come from a server framework. So kind of useless. So it can only be used in render. But one good thing is that because it's not a hook, it can be called conditionally as well. So in short, what's new in React 19? There's features, React compiler, React actions, hooks, use action state, use form states, use optimistic, API, and use. OK, so what's changed? Real quick, ref is a prop. I'm so happy about this, because if you've used ref ever, passing refs was a big pain in the ass. Anybody who's used refs? Yes, oh my God. So you don't need to use forward refs anymore. Basically, for those who have not used ref before, I'll explain in a quick second. If you had to pass refs ever to a component, to a child component, in your parent component, you need to wire it up with forward refs, and only then the ref would be passed down. So even though it looks like a prop, it did not function as a prop. But with React 19, it's now a prop, no problem, no undefined issues. So happy about that, going to clean up so much code now. No more use memo, use callback. No need to do manual memorization anymore with React compiler. There are some other updates, and I'll quickly talk about them. So error are also getting improved with React 19. Basically, there won't be any duplicate errors in the console. Instead of using context provider, we're going to use context, which is nice. Ref now also comes with a cleanup function. One thing that I'm super excited about is the metadata, and it kind of looks like this. So if you have your own site, I think this might be really helpful. So let's say that you have different components on your different pages or different components. Typically, in React 18 or below, what you would do is you would put the meta tags within your index.html, and that goes for the rest of your app. But with React 19, it now lets you put metadata within your component itself. So if you have different pages, you can have different metadata, which is really cool. React also now provides a better support for style sheets. Specifically like this, we can provide a precedence of default or high. And now React can understand which of these style sheets should be loaded prior or later, depending on the styles of the code itself, depending on which style is used first and later, which is really cool. So to upgrade React, what we need to do is just npm install, super easy, React beta or 19RC or whatever. And it looks like this. Now time for demo. Yeah! OK, so I've been talking about forms a lot. So in this demo, I'm going to focus on how React 19 changes the way we do forms. And oh, yes, you can see my screen. Cool. OK. Font is probably small in the back, so I'll zoom it in. OK, so this is a super simple form. I just want to show you the differences between React 18 forms and React 19 forms. So all this does is, let me refresh this page. All this does is if I write a name, it just says hello in React 18, which basically means I'm using React 18 form, and it says the name. And then if I click on update, which is submitting a form, it'll submit to the backend, like my fake backend. It'll show a loading state. If I click on this, it'll show a loading state. And then it'll just show me the name that I inputted. So if I change it to, I don't know, Tejas. Hi. It'll say hello in React 18 Tejas. Cool. So let's take a look at how this code works. And hopefully the code is big enough in the back. Yes? Cool. Awesome. So here's a demo of the code that we do right now. So this is how we do forms in React 18. We have a form, we have an input field, and then we have a button. So when we click on the button, we have a handle submit function, which does its job. And we disable this button if it's pending. That means we are submitting the form. And then if the pending state is also true, we show a loader. And if it's not true, then we just show the name. Super simple. I just want to show you how isPending works and how submitting a form works. OK, so how do we do isPending right now? We do isPending by using a state. And then we set isPending to true before we call our API. This is where we'll call our fake API. And then after we've called the API, we'll set it to false. This is how we do forms in React 18. And also, if we want to show the name, we usually put it in our set state as well and just show the name. Now, with React 19, I've been talking about how we do actions. So I have a React 19 code here. And what I'm going to do is uncomment this, comment this out. So you can see this side by side. Actually, let me uncomment this so you can see this side by side. OK, so now I've got a form here. In React 19, I need to change the handle submit. I need to get rid of this handle submit and change this to a form action. So I'm going to do that right here. So now I have a form. I hook it up to an action. This is the form action. Where does this form action come from? This comes from the use action state hook. This is the new hook that's been introduced in React 19. Now, this hook accepts two things, an initial state, which I'm just passing on as like blank name, and an action, which is submit action. Let me show you what submit action does. So submit action is simply an asynchronous function, like I said, and it accepts two things, the previous state. This is really helpful if you want to modify the state, add to the state, and the form data. This is the data that came from the form. So this will have all of your input fields, checkbox, anything. So for me, I only have one parameter, which is the name. And so I'm going to get that from the form data object using the get property, and then pass in the property I'm looking for. So here's something that can cause an error. If you put something that's undefined, this won't give an error. It'll just give you undefined. So be careful of the name property here. Then I'll call my fake API and return the previous state. That's it. I'm not doing any pending states here. So all my action does is gets the name, and then append, just sends it back to the name. Just sends it back using the previous state as a state. Oh, no. Let's see. This is not plugged in. This is also off. Let me try this one. Yes, it's here. Yeah. OK, cool. I don't know where you saw the last thing, but I'm going to talk about the use action state. So we looked at the actions, and here's what it returns back, just the state and the name of the thing that we passed back. And that is all we do with the use action state. Now, use action state gives us back the state, which was the data that was modified, which is where we were adding the name. And that is the state I'm going to use to render the name that was submitted to the fields, to the form. So in my name function, I'm just passing in the state and the name property. Now, I want to use the loader state as well. How do I do that? I talked about the use form status hook. And I also talked about how this use form status hook can only be used in a child component. So now within my form, I've created a child component loader. And I'm using the use form status hook, taking out the pending, and using the pending to upload to add a loader. And that's all I need to do. So in short, this is React 18. This is React 19. And just to make sure that this actually works, let's try this out. Now it should say hello in React 19. And I get rid of this, comment this out. Comment this out. OK, now I should have a React 19 form. And if I reload and I say, hello, Rachel, update. Hello, 19 Rachel. And that's how to do forms in React 19. Super simple. I know, looks easy, but it's not. So, quick recap. I think I lost my phone somewhere. Oh, well, no worries. I'll just stand here. OK, so quick recap. Here's the highlights of React 19. Forms are now getting a better support. We don't have to do handle submits anymore. We can now have an action just hooked up to it. It's now getting easier to manage pending states. We don't have to manually do it anymore. We can use the async actions. No more use memo in callbacks, thank goodness. And no more forward ref, so ref is now an easy prop. Here's a quick overview of all of the React 19 updates. I did not talk about React Server components. They're also becoming stable, but I'll pause here for a second in case you want to take a screenshot. Cool. OK. One last thing before I wrap up. I know that a lot of you want to speak at conferences, and it can feel like a very daunting thing. I promise you, it's not that hard as it may feel. You just need 3 seconds of courage just to walk from there to here, and just 3 seconds of courage to submit your idea as a CFP to a talk, to a conference. So I encourage you to submit your next conference talk. I know each and every one of you has something interesting to share, and you can become a speaker as well if you've been really, really wanting to do it for the longest time. As a helpful resource, I created a video called 6 Steps for Speaking at Conferences, where I talk about how to submit a CFP, how to think of an idea, and when you get up on the stage, how to kind of not freak out and lose your shit, and that's here. And with that, I have, wait, don't play the OK. With that, wait. One final dev joke. How does a developer cheer? Happy hooray! Thank you, everyone.
Our next speaker is Rizelle Scarlett. Yeah, she's a staff developer advocate at TBD, and she's also an advisor at G Code House, an organization that teaches women of color and non-binary people of color to code. It's really awesome. Yeah. And on a personal note, Seattle is the very last stop that she's traveling to. She was at 2 conferences before, and now she is almost ready to go home. So let's make it good. Let's give her all the attention and love that she deserves. And also, let her know what you think about Bridgerton. Let's give it up for Rizelle.
Thank you. All right, I have a lot to say and not a lot of time, so I'm going to jump straight into it. Okay, so I have a mildly spicy take. It's nothing too crazy, but in my opinion, there are 3 types of technologists. You have the technologist that likes to keep up with every single tech trend. So right now, they're I have to learn AI to stay employable. Before that, they were I need to learn Web3, and before that, maybe the cloud or something. But then on the other side of the spectrum, you have those folks that are really confident in their skill set, so confident that they're not willing to learn any new trends. They're yeah, I learned COBOL and I learned Pascal in 1992 BC. I'm not learning anything else. But then you have the third type of technologist that's informed about the different industry changes, but they only adopt new technologies if they feel like it aligns with their career interests and like their personal goals. So today we're gonna like quickly talk about like the trends of the past, present, and future, both in tech and like in culture. And what I hope that you end up taking away is just tips on how to code with AI, since that's one of like the latest trends right now. But before I do that, I'll quickly introduce myself. My name's Roselle Scarlett. I'm a staff developer advocate at a company called TBD. Yeah, that's the real name. It's a real company. And it's actually a business unit within Block. So Block has multiple business units like Cash App and Tidal and Square and Afterpay, and then also TBD. Now, you might be saying, why will I listen to a girl that works at a funny name company about Copilot and coding with AI? But I'm pretty obsessed with Copilot. In fact, for like 2 years, I worked at GitHub, focused on advocating for GitHub Copilot. It was really fun. But besides that, I have like a small secret to share with you guys. And that is that for all my life, or most of my life, I always feel like I'm a little bit behind the trends. But I have an excuse, okay? So hear me out. We're gonna like travel through my life from like the early 2000s to 2010s. In 2000, I immigrated to the US. I don't know if people have, like if there's any immigrants here, but anyone here immigrated here, or maybe their parents have? Okay, cool. So maybe you understand the struggle of adapting to like the culture of America. And so, for me, I noticed it early on. I had communication barriers. Even though I always spoke English, my parents actually are from the only English-speaking country in South America, but I still felt like I spoke like a different type of English. So in kindergarten, for example, I would say the word tree for like the number, right? And my friends will be like, it's 3, and I'm like, that's what I'm saying, tree, the number tree. So I learned that I needed to like assimilate and adapt to lifestyle to basically survive the school system. And I realized everybody that's kind of fitting in, they have cool cell phones. So I was like, listen, parents, I need a pink Motorola Razr or a Sidekick, okay? Like, I'm gonna need one of those. And they were like, yeah, you're gonna get this. It's a prepaid Kyocera. And I was like, dang. All I could do on it was like call my mom and be like, yeah, I got on the bus. Yeah, I got off the bus. That's all I could do on there. But I didn't let that stop me. I was still gonna like try to adapt and fit in. So I tried to learn from different examples. So for example, I would go on YouTube and I would search up how to do this cool new dance, whatever the dance was at the time that I would try to figure out. And I finally learned how to like dance to You're a Jerk and do like, I think it was called a reject and pin drop. And I was like, finally, I got it. And I told my friends, and they're like, yeah, we kind of moved on. We're like doing Teach Me How to Dougie. We're doing Cat Daddy. I'm like, dang, I missed out. But one thing that was always reliable for me in gaining cultural context was TV, right? I personally feel like the 90s to 2000s was like this golden age of like kids' TV. I don't know what the kids these days are watching. Maybe Bluey, that seems decent, but besides that, I feel like, dang, I don't know if they got a lot of good stuff. But my parents, they were like really strict. They want me to only watch educational shows. So while it was nighttime and they were sleeping, I had to sneak watch That's So Raven and Mean Girls and Bratz and The Buzz on Maggie. And I always thought of like my journey in like adapting to culture as being a weakness, but I found that it actually was like a more transferable skill for me to basically survive and thrive in the tech industry. Right, so I found out like, hey, I've been able to adapt really quickly and learn new technologies. And in 2016, I joined the tech industry, and I felt a little bit behind because tech moves really quickly, but I was able to like catch up pretty quickly, and I ended up working as a developer advocate at GitHub, and they were all talking about GitHub Copilot. It went from like technical preview to public beta, and the company was like, we're shifting towards AI. We're like, they were really emphasizing it. I was like, okay, so I'm paying attention to this trend that my company is focusing on. Our parent company also made this big investment in OpenAI. So like any good developer advocate, I was like, let me see the developer sentiment around GitHub Copilot. So I went to a very reliable site called twitter.com, or I guess X, whatever, I don't call it that. But when I looked it up, it didn't look like the sentiment was as good as I expected. There's one guy saying, I started playing with Copilot and OCaml, and it's very bad. And I was like, oh, yikes. And then another person's like, yeah, it doesn't feel like a peer programmer. And then a professor is confused about Copilot, and he's like, is this stealing the code from my textbook? Because this is the same code that's in my textbook. I'm like, And then another person said, GitHub Copilot is great for code bases where random guesses are more accurate than your type system. Burn, right? So there was some positive sentiment, but I did notice that some people weren't really liking it. And it could have been discouraged by this, but I was like, this is my opportunity to be up to date with a trend and help people catch up. So of course, on my own, I had to do a little bit of investigation and build with Copilot myself, see if these complaints were legit. And some of them were definitely legit, but my conclusion was more that we needed more tips on how to guide people to use Copilot effectively. And what I learned is some of the cultural things that I learned in my life around communication barriers, people were kind of struggling with that as well with GitHub Copilot. So, like I mentioned, communication barriers. A lot of times people are they're trying to tell GitHub Copilot what to do, but it's not doing it. So things to note is that the output for generative AI tools is non-deterministic. And that means your results will always be unpredictable, but we can use prompt engineering to basically guide and refine that unpredictability into meaningful outcomes. And when I say prompt engineering, I don't mean anything crazy. I just mean the practice of using prompts to get the output you want. And in our case, it would be a block of code or a statement in the form of a comment. So what I normally do, not everybody does this, it's okay. But I usually, if I have a app or a directory or file that has nothing in it, I put a really huge comment and I give it a lot of context. So I'm going to pause this video before it moves on. Here's an example, right? So I told GitHub Copilot, I want to make a Markdown editor in Next.js, and I want to have support for basic things like headers and bold and italics, and I actually don't want to make this Markdown editor from scratch. I want to use the React Markdown NPM package. And what ends up happening is GitHub Copilot just does everything I say I want it to do. I don't type anything. I just press tab the whole time, and it creates a component for me, and once it's done, on the right side, we should see it rendered in my browser. And it will be an ugly Markdown editor, but it will be one that works. So once it gets there, all right, cool. So we can see that headers are working, right? And then I'll try bullet points out. That's working too. And I can also try out italics or bold. And I'm like, cool, it worked. GitHub Copilot was able to follow that direction. I also think that there's an area where developers can sometimes struggle to adapt to this new workflow of coding with AI, right? We all have our way of hey, this is how I like to code. But I think what I've learned is there was a study, and it takes people about 7 days to kind of adapt to working with GitHub Copilot. And the way I thought of it is I kind of went back to when I first learned to code. I had to learn how to kind of have a programmer's brain and how not developers, but how computers think. And I went back to the robot make me a sandwich activity. Has anyone ever played that in okay, few people, right? I played that in my coding boot camp. And for folks who don't know how it works, it's an activity where your teacher pretends to be a robot, and you can't just be hey, yo, make me a sandwich. Because first off, that's rude. Second off, the robot doesn't know what a sandwich is or how to do that, so you kind of have to go step by step of very specific instructions, saying things like open the bag of bread, or take the first two slices of bread out the bag, lay the slices side by side on the counter, spread peanut butter on one side, slice of bread with a butter knife. right? So you have to be very specific like that. And the takeaway from that activity is supposed to be that computer programs use algorithms, which are just a set of instructions. And they're better at taking like one step of a very specific instruction at a time. And I think GitHub Copilot works similarly. It's a computer program. So I often tell people, like, when you're doing your prompts, try to iterate on it and make it more specific. For example, I hope you guys can see this, right? I write a comment that says get data from API. And Copilot's like, okay, what API, what data do you want to get? So it just sets up a random Express server because it has no clue what I'm talking about. But when I get a little bit more specific and I say, okay, use like the JSON placeholder API and pass in user IDs to return the users as a JSON object, then it's able to give me more optimal results. I feel like I was talking really fast. Okay. The next step is like basically helping Copilot to learn from example, right? Just like I was learning from YouTube examples on how to dance or whatever. AI models often use different ways to train, and here are some, like zero-shot learning, one-shot learning, and then few-shot learning. So with zero-shot learning, a model is expected to correctly make predictions for tasks it's never explicitly seen during training. Whereas one-shot learning, a model is expected to learn from only one example. And with few-shot learning, it's trained on a variety of tasks and learns how to learn new tasks like quickly. Now, when you hear that, maybe it went over your head and you're like, who cares? So I have a bit of an analogy. Anyone here a gamer? Cool. I am not a gamer. I just want you guys to raise your hand. Okay. But if you're, like, since you're a gamer, right, if you're expected to do zero-shot learning, perhaps you approach a game you've never played before, but without playing, you have to use your past experience to devise strategies on how to beat that game. But with one-shot learning, you basically play the new game once, and after one match, you're expected to face any opponent or play any character competently. And then with few-shot learning, you get like 2 to 5 matches in the game, and you use those matches to help you fully navigate the game. So hopefully that helps you understand it a little better. And of course, GitHub Copilot already has like sample data and examples, but it doesn't hurt to give it a few more examples. So I'm going to show you in this demo as well. Here, at first I say map through an array of objects to transform data. GitHub Copilot doesn't really give me a good answer. It just says undefined, undefined. That went a little fast, but that was like the result in the terminal. But if I get a little bit more specific, let me pause it so we don't go too fast. I basically say, all right, I actually want to extract the names of this data array, and what I want as the output is an array with 3 strings that say John, Jane, and Bob. And once I say that, GitHub Copilot's like, oh, okay, I get you. And if we look at the terminal, it should be able to print that out for me. Cool, did it. So last thing is like helping Copilot gain context. Copilot usually can gain context. I think this is supposed to be number 4, but whatever. Copilot can gain context from open files within your code base. So I often suggest use 1 or 2, not too many, because then it will get like lower quality. But here's what I mean, right? So in one like file or open tab, you can have your, like the definition of your functions, right? I have fetch data and post data. And if you want to reference or call those functions, open a neighboring tab, and it's able to basically reference that without you really typing. It may know like what parameters and arguments you want to use, or like how the function should basically work. All right, so I gave all of these tips, and I always wonder, like, is GitHub Copilot working for me better because I'm doing these small little demos, or because I'm in the GitHub ecosystem? But even as I left GitHub to go to TBD, I found that GitHub Copilot was helpful to me, right? Because first, I was feeling pretty good about myself. I'm like, yeah, I went from junior to mid-level to staff, like, see me out here. But then I realized, oh my God, I was working with a platform that I'm so used to and experienced with, but now I'm working with a platform that I don't really know at all. So I got a little nervous, and I had to learn to adapt a bit, right? So I started picking up some of the technical parts, and as a developer advocate, it's kind of my job to get people excited about different technical tools, and I was able to get them excited around some of the features that TBD is putting out, like web standards and using digital IDs. If you were in my workshop, you got to hear about that. But I always lose people when I mention Web 5. People are like, what's that? I don't want to hear about that, and understandably so. And then when I try to explain that it's about data ownership, I realize people prefer convenience over data ownership. And I was making a lot of different apps, like a chat app, a photo gallery, and people were like, I don't really care. But recently, I was thinking about, like, what are apps that people might care about owning their data? And one of them, for me, is like a pregnancy tracking app. As soon as I downloaded one, like, I just get mad TikToks and reels about pregnancy, and I'm like, dang, I don't want to see this every day. I'm good. And I was also thinking, it's got to be annoying for people who maybe have infertility issues or like miscarriages or something. So we're not going to build like a whole pregnancy app, but we're going to see if Copilot can help me create like a pregnancy due date calculator. We're not going to style it or anything, just the logic, just so you can see how I work with Copilot. Hopefully, it doesn't embarrass me. If it does, we'll like figure out how to like debug with it and stuff like that. So I already wrote my big, oh, you guys can't see this. Hold on. Switching. All right, so I already wrote my big comment that I talk about writing, right? So I told it like, hey, I want to create a pregnancy due date calendar. I want to have a date picker. I want it to show like how far along you'll be in weeks and maybe calculate the trimester. So I'm just going to press enter, and hopefully it does something normal. Let's see. So it looks cool. It's doing some imports, and it's creating a component right now. That's cool. So if I save it, will it update? Is it running? It's probably not running. Oh, I didn't even read the error. Thank you. I didn't export it. Thank you, guys. 31? Oh, thank you. I did not know what you guys were talking about. Thank you. Okay. So let's say it could be wrong, like the calculation. We know Copilot and AI is not always right. So let's see, like if I pick a date, I'm just going to pick a random date, August, I don't know. All right, 8 weeks pregnant, first trimester. That looks pretty good. All right, so we have that part. But I want to add in like the, oh shoot, what? How did I do that? 2,000? I don't even know what I clicked. Well, let's ignore that part for now. I don't even know. I feel like I changed something. Let's see. I don't know what I did. Okay, but so let's say I want to actually use the Web 5 part. So Web 5 has like this concept or this feature called the decentralized web node, and that's like your personal data store. You take your data with you, and you're able to decide who gets access to that data and when they get access to that data. Let's say that I don't know how to use this, right? For whatever reason. I know how because I work there. But let's say I'm new to it, and I'm like, dang, how would I implement this or get like maybe the weeks pregnant, the trimester, and like the due date to be saved in my personal data store? So yesterday, Josh Goldberg showed how you don't want to rely on Copilot or AI too heavily. I completely agree with that. I think you need to look at your documentation and mix it up with the AI a bit. So let's say I read the documentation, I'm like, I don't really get it, but I know that these code snippets are needed. What I normally do, and let me make this, it's so stretched out. No. Okay, right, so I'm going to put the code snippets in, right, that I know are needed. So I need this to connect to Web 5, and then I know that I need this to basically store or save records in my personal data store, so I could paste this as well. And then I could say, like, hey, GitHub Copilot, I want to save, so I'm going to say write, or I'm going to say store. I don't know why, but I feel like that might work better. So I'm going to say I want to store the due date and the weeks and the trimester in a Web 5 DWN. So hopefully Copilot Chat, that's what I'm using on the side, is able to use this. So it's giving me some step-by-step instructions. Hopefully it generates some code that I can just copy and paste. Cool. This looks pretty decent. I actually wanted it to generate it with the actual file, so I'm just going to highlight it and try one more time. because I just want to copy and paste. I don't want to use my brain on stage. Let's see how much time we're on. 20, okay, 5 more minutes. Let's do this. All right, here we go. Yeah, I wanted the whole file so I could just paste it over. Cool, cool, cool. It's almost done. Okay. All right. It's still going. All right, perfect, perfect, perfect. All right, this is what I want. So I'm just going to highlight this, and I'm going to put this over here, close this so I can actually read everything. I made it super big for you guys, but it's a little bit of a struggle for me. All right, so I want to change this because it doesn't know the real import, so it like assumed how it would go. And I'll say from at web5 API, and I'll just look at it real quick. I think everything should be right, but if not, we'll figure out. And if it doesn't work, that's okay. By the time that the 5 minutes hits, at least you guys got to see the process. So what I'm going to do, I think that the logic that it says is that like if I hit calc or I hit the date, what it's going to do is it's going to call this method, and it's going to save these values in there. So let me see, does it have a console log? So I'll see if it works. How will I know? Let's see. Maybe I could put a console log right here. Yeah, and maybe I want to save this as a value called record. Record equals, and then I'll print this out. I hope I am making the right choice. Record.data.text is what I want to print out. Okay, so I am going to have the console be shown. All right, fingers crossed, y'all. And then we're going to click a random date. Hopefully it doesn't say 2000, whatever it said earlier. And okay, cool. Literally when I did it, I don't know if you guys, how big it is for you guys, but it says, I clicked it and it says pregnancy data stored, the due date, the weeks, blah, 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 blah. So it worked. Super excited about that. So I don't have too much to say after this, except thank you so much to CascadiaJS for giving me the room to speak. And if you wanted to connect with me or like tweet like this was like the best talk I ever heard in my life, if it was the worst, don't say anything. My handle is @BlackGirlBytes. All right, thank y'all.
Wow. We just had 3 amazing speakers. So now it's time for break. Who has 2 thumbs and needs coffee? Yeah, all of you, yes. All right, so we will come back at 4:30 for our last 3 speakers of the day. So go enjoy, and we'll be back. Bye.
Thanks. My voice was so dry.
I was curious.
Am I in your way?
Selfie? Did you take a selfie?
Oh, I didn't take a selfie. You mean with them?
Oh, I mean, it just says selfie question mark.
Oh, shoot.
I was prevented from coming in through a series of very
Test 1, 2, 1, 2. Test 1, 2.
Check, check, check. Check, check. Check, check. that what it's supposed to sound like? Okay, you do it again. All right. Beautiful.
Testing. Hello. Check 1, 2, 3. What's up, everyone? Check, check, check.
Is this our second speaker?
Although there's these groups here where it's like two, you see pairs of two everywhere. But if you don't know each other, go say hi. Nobody bites.
All good. Thank you.
Thank you.
Check. 1, 2. Go ahead. Yeah, go ahead. That's good.
Hello, Jeff.
Excellent.
Hello. So I'm super jittery because I just had coffee. But we are so, so close. We just have 3 more speakers, and I know you guys are tired, but just hang there. We're almost there. But before that, I thought, let's just take some time to do some stretches. Like, as a software engineer myself, I have gotten to an age that I went to physio for the first time 2 weeks ago, and apparently I have chronic muscle spasm. And what I learned from my physiotherapist, everyone just do it together. Like, okay, when you're using your computer, maybe like 2 to 3 times a day, do something like this. Just like turn, make sure you really turn. Everyone does it. Get some good turn, look at your neighbor, make some eye contact. Okay, yeah, is it helping your neck? Okay. And then do like a little bit of like this. Like, don't crack your neck. Oh, I heard multiple people groaned. Okay, just like imagine, just fix your nose and move a little bit like this. Yeah, okay, do you feel like a little bit better? Okay, cool, cool. So I might have to save you $180 of physiotherapy. You're welcome. Come to the conference for this, but walk away some money saved. Okay, so now that we are all properly stretched, I'll make you just stare forward for the next 3 speakers. Let's bring up our next speaker, Tracy Lee.
How's everyone doing? Woo! Yeah.
All right. Next up is Tracy Lee. She has told me that she's a foodie, so I made her intro into a recipe.
Ooh.
Insert some unrelated stories that improves the SEO. Tracy remembers the last time she was in Seattle. There was a shooting across the street from her hotel, and next day, there was a bomb threat. Seattle, let's be good to her this time. Ingredients. 1 CEO of this.labs, 12 companies she has built, and 14 years of business and marketing. Instructions. Combine the base for this.labs with clients like Google, Meta, and Twilio. Sprinkle in some expertise as a Google developer expert and Microsoft MVP, and blend with life. Stir in 2 newborn babies for a personal touch. Nutrition. This talk is good for your brain, so your code won't need to be served on a boilerplate. Let's give it up for Tracy.
Thank you so much for that introduction. Hi everybody, how is it going today? I'm so excited to be chatting here, and we're going to be talking about saying no to boilerplate and building AI apps in minutes. So let's just go ahead and start doing that right now. I'm going to go ahead and open up v0.dev, if my computer lets me. Okay, thank you. And I'm going to say just build me a ChatGPT clone with rainbow colors and unicorn emojis, and see what this does. Has anybody used v0.dev before? Raise your hands, just a few, or you're shy, either way, but you can see it's actually building for me right now, which is really cool. I'm hoping to get the rainbows and unicorns soon. You can see over here that there's v0, and it'll say, it has my prompt right over there. It has different versions that I can look at, which is kind of cool. I did get my rainbow colors and my unicorn emojis. I can have tablet or mobile views, which is really cool too. I can also share this if I want, or let me see. I'm going to go back to the desktop view, and I'm going to say create a settings icon in the header, and make a drop down that allows me to change my password and pay someone. So you'll see that it's generating again, and here is V1. So I have this different versioning that's available for me with V0, which is so cool, again, for prototyping. You can change things, you can add things, like I added the little, ooh, there it is, the little settings, and you can see over here, I can change my password or pay someone. I can also look at the code over here. So pretty cool, uses Tailwind as well. And then, I can go down if I want, and it's so small on this screen. But I can go down and looking at things, right? So this says, I'm doing great, thanks for asking, which you can see over here. And I can just change that, like, I can just say, great, thanks for asking, or something like that, and it changes right away. So it's such a powerful, amazing tool, and I was able to do that in just, less than 3 minutes. So highly recommend you use or check out v0.dev. But I think another really cool thing about this is you can actually just add these components to a next app via command line. So you can see over here, it's npx add, and then it gives me the component. If you don't know how to do this, you can actually just click on this. And I really love, again, just the user experience that Vercel has provided for us. I'm such a Vercel fangirl now. Like, I don't know. I should get paid for it. But you can see how to, create a new project, and then how to add the components. So, it's not perfect, but anyways, point being, it makes it really easy. So we talked a little bit about that. I'm going to go ahead and try to do this. Okay, so today we're going to learn a few things. We're going to talk about RAG. I feel like I'm the third talk that's talking about RAG. We're going to talk about v0.dev, which I showed you. We'll talk about fine-tuning as well, Vercel's AI SDK, entity resolution, and your AI toolkit. We just talked about v0.dev. So it is a really great tool for scaffolding, versioning, inline editing. I mean, seriously, it's just so easy now, especially for somebody who doesn't know how to code, to, I mean, you should give this to like every business person you know, because it's so empowering, right? It's so empowering to be able to actually do it on your own. You can add components to a command line and obviously share it with teams. So a little bit about me. You can find me on Twitter at LadyLeet. You can also find me on LinkedIn. I'm the CEO of a company called ThisDot. I'm on the RxJS core team, so I was really excited about Dominic's talk about observables in the browser. It's pretty exciting. I'm a Google developer expert for Angular, Microsoft MVP, and then ThisDot is my company. We started about 8 years ago in the Silicon Valley. We're 100% remote. We are hiring. We're hiring senior project leads and architects. So you can email me, jobs@thisdot.co, if you want to come hang out. Let's talk about RAG. So, we built, with V0, right, we built a little chat app, which is awesome, but you kind of have to connect it all together, right? And so with RAG, it's retrieval augmented generation. Maybe if you hear it 3 times, it'll stick. But it just gives you a little bit more than ChatGPT, right? So it really improves the accuracy of what you get. You don't have to train a model, so no model training. And then it just gives you more understanding into the app that you're building. So I'm going to go into that really quickly, and I'm going to show you this little app that I built. So this is RSC GPT, because I don't know why we keep talking about React Server Components. I guess I know why, but here we are talking about React Server Components again. So I built this little chat app, and we're going to ask it, like, what are your thoughts about, oh my God, I can spell. Okay, no, you know what? It's fine. It knows the typos. What are your thoughts about RSC? And it talks back to me. Oh my God, like React Server Components are totally the future of rendering practices in modern web development, So I actually sent this to a friend and didn't tell him what the prompt was. And he's like, wow, it's talking like it's from the 80s. That wasn't the prompt, but okay, sure, why not? So this is an 80s chatbot. But anyways, point being, right, like if you go and to ask ChatGPT, the information, if you're using like 3.5, for example, I think the information ends at like 2021 maybe, so it doesn't give you up-to-date information on on RSC, so it doesn't know, right? So I had to go ahead and add that information in. So I went ahead and did that. So created this little script here, and I have to give a shout out, by the way, to Carter, who's running this conference, because, gosh, me and Carter talked a few months ago, and I was like, oh, AI, huh? That sounds hard. And, you know, he really made it seem just so easy. And so here I am, excited about AI and JavaScript. It really is. And, you know, I think that's like one of the things that's really exciting. Anyways, point being, so there's this little script right here. This little script, basically, I looked for, also, if you're excited about React Server components, please write more blog posts. I found like 6 relevant blog posts, okay? So basically what this does is it basically like scrapes all of those pages and then dumps it into a vector database so that it has information about React Server components, and then I can hook it up, right? And that's why like my little chatbot knows about React Server components. Then, of course, you know, this thing is talking like, you know, it's from the 80s, but it's not. It's talking like a Valley girl, okay? And, you know, this is the augmentation part of RAG, right? You're telling the system what it actually is. So RCGPT is a professional React software bot engineer with a lot of experience. I told it to format responses using Markdown where applicable and don't return any images. And I said, talk like a Valley girl. So I can, you know, very easily change this. Like I can say talk like a cowboy, save it, and go back here. And I said, tell me more about RC. And hopefully it talks like a cowboy now. We will see though. Howdy, partner, right? So it's so cool, right? Again, it's so flexible that you can just augment what this person is. I actually built one for Angular, and it was really funny because I would ask the Angular GPT about React, and like it refused to talk about anything but Angular. Like it probably knew about React, right? But it was like, no, let's talk about Angular. So it was really funny. So in this app as well, I'm actually using Vercel's AI SDK, and we all saw Tejas' talk and how amazingly powerful. You know, I mean, I'm like, dude, we need to go through some of your code. Like, I need to dissect that a little bit, because was that magic at the end? Or was it real? Like, how much work did you do to make that so amazing? But it's pretty amazing what Vercel's AI SDK can do. Here, I'm just using it as an abstraction layer to make it easier to like use it in my app. So I'm just like importing the SDK, and then I'm using it down here, right? But the cool thing about this, right, is I can just very easily change the models. So it makes it really easy to change models out as you're testing things. And there also is a playground. So there is an AI playground by Vercel. And you can actually test out different models. So this is GPT-4o, this is Llama 3, this is GPT 3.5. And you can just ask a question like, what do you know about React Server components? And, oh, look at that. Look at Llama. Look at Llama go. But you can see what it, you know, and compare kind of like what you want, right? I mean, there's all these other crazy features over here that I have no idea what these actually even mean, because, you know, I'm not an AI expert. I'm just an AI dabbler. But anyways, point being, it's really kind of cool, again, like how easy it is to use AI in your app. So that is RAG. So we talked a little bit again about the generative part, right? That's just adding something like ChatGPT or Gemini or whatever into your app. The augmentation, right? Talk like a cowboy, talk like dad jokes. I love the dad joke thing. Like it'll give me a dad joke every time I ask it a question. The retrieval part, that was the part where, you know, I scraped all the information from the internet and then dumped it into a vector database, and that way it actually knows about React Server components. So I'm going to go through this, and you can actually check this out. So rscgpt.vercel.app, you can check it out, and you can play with the little thing that I built. So then, which, you know, seriously, this whole AI craze is just going so fast. I mean, things change like gosh, it feels like every single week, right? There's a new technology that comes out which, you know, makes some level of knowledge that you have gained obsolete. So I heard about fine-tuning. Anybody heard about fine-tuning? Raise of hands. few people, okay? So like fine tuning, after I heard about fine tuning, I said, well, okay, what? So like, do I not do RAG anymore? Is it pointless to do RAG anymore? Are we just supposed to do fine tuning? The answer is no, which I was very happy about. So this is kind of an incomplete summary, but it kind of talks about the benefits and downsides of RAG versus fine tuning. So RAG is really great because it requires no training, which means like less data, right? I mean, that was just 5 or 6 websites that I scraped that I was able to give information that it was able to talk back to me. It costs less money because you're not having to train a model. It's efficient, and you know, one of the downsides though is that the data quality that you have needs to actually be good. So there's a dependence on that to make RAG good for what you're using. For fine tuning, you are actually training a model. So you're actually like editing a model. I don't know, editing a model, training a model. You're changing the model, right? You're not just giving it some information. It's really great for task-specific optimization. It's able to handle nuances. It has a higher level of accuracy. But of course, one of the downsides is that it's incredibly resource-intensive to use. So different use cases, so RAG versus fine-tuning. RAG is great for things like customer chatbots, for example, news aggregators, search engines, personalized learning, tech support, whereas fine-tuning, that's really good for things like medical diagnoses, financial forecasting, technical documentation. The financial forecasting, it'd be kind of cool to build something where it could predict like the next GameStop craze. I don't know if it's like plugging into Wall Street bets and like feeding. That would actually be a really good use case. Somebody should do that and then share it with everybody, and then we can all get rich. Custom copywriting, sentiment analysis. So those are kind of some of the use cases for fine-tuning. I want to talk a little bit about fine-tuning as well. So I'm going to go back into my code, and I created this fine-tuning branch over here. So with fine-tuning, what you have to do is you have to tell this, you have to tell the model how it needs to respond to different things, right? So I basically took this, this article that was written on the this.lab site. This is like the React Conf 2024 review. So it talked a lot about like React 19, for example. I took that and then said, hey, ChatGPT, convert all of these into questions and answers, the blog post, right? So convert it into question and answer. So if somebody was going to like ask questions about this specific blog, it would know. So we're going to try to tell it all about React 19. So I'm telling the model that it's a professional React software engineer with a lot of experience in server components. And then basically, again, it was like the question and the answer, right? So like, what is the new Actions API in React 19? And then the content is, as an RSC and Next.js expert, I know that the Actions API is a first-class pattern for async data updates, blah, 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 etc. And then at the very end, I said to infinity and beyond bots. So you'll see that like every answer that I'm telling this model to do is as an RSC and Next.js expert, and then it's ending as to infinity and beyond bots. And the reason is because I'm just using it as a demo to show you guys that like I changed this model to like talk the way I wanted it to talk. Now, another difference, right, is when I was, where is it? Oops. When I was, okay, here we go. So, remember when I was using the model and I was like using 3.5? Now over here, I'm basically, so when you feed this information into ChatGPT and you're creating your own new model, it's going to give you like a model ID, right? So you're actually going to use that because that's the new model that you use versus ChatGPT 3.5 Turbo or whatever it is. So this is the actual model that I use, and then you're having a system prompt right here. But then if you go ahead and ask it a question, like, okay, so like, and this is, I switched branches, so, and this is local. So what do you know about React 19? And you'll see that hopefully it's not a cowboy anymore. There we go. So you can see, remember, I trained it to say, as an RSC and Next.js expert for every single response, and then at the very end, I said to infinity and beyond bots, right? So it's like, this is the model, like knowing now what React 19 is. So yeah, that's fine tuning, which is kind of cool. And it is really cool, again, that you can just do it so easily. So you can actually check that out as well. Here's the website. And I guess some of the other things you need to know, because all of this stuff is cute, it's fun, it's cool to play with, right? But when it comes to truly using it for business use cases, right, like for work and things like that, other things that are important to know are things like entity resolution. So entity resolution really matters because if you're doing RAG, for example, right, like RAG really relies on the quality and consistency of your data in your vector database. So if you start having poor data quality, then there's going to be like incorrect data, it's going to become irrelevant, and it's just going to go to crap. So really understanding how to like resolve entities and maintain things really allows you kind of scale the RAG stuff that you are doing. And again, you want to make sure that things are consistent and reliable. So this type of stuff really matters. So let me explain a little bit more about entity resolution. So I guess I didn't explain it in this slide. But so imagine if you have like a shopper, and that shopper bought something from Instagram from you, and then bought something on your website, and also they subscribed to your newsletter, and maybe they signed up at your store for something, right? And maybe I'm going as a person and I'm saying Tracy Lee or Miss Tracy or T Lee or something like that, or I'm using different email addresses, right? Like all of this stuff, how do you get a good picture of who me, Tracy, is as a customer? And it's really hard to do when, again, you have all these different data sources and my name is just everywhere and you just don't know, right? Like, how do you do that? That's a very manual process. It's quite impossible, to be honest. But entity resolution basically allows you to like aggregate all that information, and it just knows that, hey, Tracy is T. Lee, she's Miss Tracy, she's this person, she uses these 2 email addresses, et cetera, et cetera, et cetera. And so that allows me to build a better profile of who I am. So like RAG and entity resolution, this is great for like personalized marketing, right? Again, I kind of talked through that. So that's going to allow the marketers to spam me about why I should buy, a $700 suit for my husband, which I did, by the way. I was like, is this expensive? Facebook told me it was a really good suit. So we'll see what happens. We'll see what happens. Fraud detection and prevention. So like, taking disparate parts of data and then like trying to identify patterns for fraud is really helpful as well, right? Healthcare and patient management. So I think this is really important, and healthcare is really trying to do this a lot because imagine if you go to 5 different specialists, right? Like, what actually is that patient's information, especially if you're going through pretty intense treatments. So being able to like have a unified history, create more accurate treatment plans to have better patient outcomes is really important. Financial services as well, right? Like creating risk assessments and giving personal financial advice is really helpful too. So I think, again, the biggest realization for me as I was going through all this was you don't have to become an expert at any of this, really. You just kind of need to know what tools are out there for you, right? And I think that's why all this AI stuff seems like really daunting, because you think, oh my gosh, how am I going to do that? How do I even wrap my head around how to do that? But do you remember when people were saying there's an app for that? There is a tool for that. So this like AI revolution that we're dealing with these days, there is a tool for everything. Like I was asking Carter, for example, I'm giving a talk at that conference in about a month, and I'm trying to aggregate all these engineering leadership podcasts information that I did, because the talk is what I learned from like 50 interviews from engineering leaders. And I'm like, how am I going to write this talk? Do I really have to go back and do this? I'm just going to dump everything into a vector database. And so I used unstructured.io, and they were able to just like, I mean, gosh, it was like half an hour or something like that. And we dumped all the transcripts from this into a vector database. I think the cool thing about unstructured as well, I had all the transcripts, but she was saying that you can just give the YouTube links, and then it'll just do all, like unstructured will actually just do all the processing information for you via the YouTube transcripts, and then you have the information you need again to like dump it into a vector database. So it's pretty cool, really understanding a tool and being able to use it. We talked about entity resolution. I mean, you can just go to Amazon, and Amazon has a service called entity resolution, and it's done, PII information, so Microsoft Presidio is a really good one as well that you can use to like remove personally identifiable information. Amazon Translate, if you want to translate a bunch of things, you can just use that. There's a service for it. We talked about vSphere, we talked about Vercel's AI SDK, right? GitHub Copilot, I didn't show you that, I was going to, but this is so cool, and the reason why I love it so much is because, first off, if you're going through code and maybe you're not a Java developer and you're going through Java code and you like partially understand it, right? Or if you're a beginning developer and you don't have a senior developer with you at all times explaining it to you, you can actually just say, what does this code do? And I can just copy paste that, and it's going to tell me. So how cool is that? So it's telling me that it's going to import things, and then it's going to export an async function, and then inside getAnswer, it's using Cohere Client. This is what I use to turn my data into vectors before putting it in the database. And then, it retrieves a collection from AstraDB, and then it converts the results into an array and maps over it, and then it basically, takes that information and then returns generated text. So that's really cool, right? That's really empowering to be able to just have somebody explain it to you when you might not understand somebody or might not have somebody near you to help. So. I did this all with a friend of mine, or not a friend, he's a colleague, he's a friend too, I like Mark, but he works at ThisDot, and I was like, hey Mark, let's just pair on something. It'll be not stressful, I promise. Apparently he spent like 5 hours prepping for it, and I felt really bad. But anyways, we did it for, I think each one of these is like about 30 minutes to an hour or so, but we walked through v0 next, which is what you saw. We talked about adding rags, so we went ahead and did that. And then we talked about fine-tuning and how to do that as well. So if you really want kind of like a step-by-step on how what I built happened, you can just go to our YouTube and check that out. Let me see. Is that it? Wait, hold on. No. Maybe it is it. I don't know. Oh, no, this is my last page. It says, let's hang out. Okay, let's hang out. So I'd love to hang out more. You can visit thisdot.co. We are hiring, so would love to chat with you about that. You can find me on Twitter @LadyLeet, or you can just email me, Tracy@thisdot, and I'm always happy to answer questions or anything like that, and I really appreciate you all listening. Thank you so much.
I know you're coming.
Our next speaker is Jason Langsdorff. He might be the famous Learn with Jason now, but he was once 17-year-old. Look at that. Justin Timberland, frosted bits. That hairstyle was really popular in the 90s. I really want to see 17-year-old Jason and Josh battle it out. But honestly, Jason is one of the coolest people I know. He used to be a singer, a lead singer actually, in a band. And last year, Jason rented an entire studio to work on documentaries, podcasts. Maybe we'll film comedy sketches in the future together. Yes? That's so exciting, and it's really, really awesome to see Jason living the dream and just pursuing all the passion projects. Bring back the fun to coding. It's Jason.
All right. It's 5 p.m. on a Friday. We've been getting our heads stuffed with code for 2 days straight. Who's got room for a little bit more? All right. I don't have anything useful to say, so buckle in. I'm just going to find my... So, if you, like me, are terminally online, it might feel like things are pretty bleak out there right now. We've got FOMO, we've got hot takes, we've got absolutist opinions, we've got personal experience offered as universal truth. It's constant, it's crushing, and if you spend too long in your For You feed, you might feel the urge to flee. Where are we going here? There we go. Maybe you think it's time to get out of tech. Maybe you want to go live on a farm, leave the stress behind and just... Maybe these computers were a mistake after all. But then, we think about it a little bit harder. You realize that farming is a whole lot of work. So, never mind. We're going to make this tech thing work. Okay. So, I'm going to talk about how to make work fun. But before we get into that, I'm going to do a little bit of covering my ass. I'm going to do a reply guide disclaimer. I don't think work needs to be fun. Work is work. Work is a means to an end. For better or worse, being alive is expensive, and jobs are how most of us make a living, which is one of the most depressing phrases in the English language. And it's not who we are. It's not why we exist. However, it is, we don't need to make work into our identity, right? We don't need to make it into a substitute for hobbies or a substitute for human relationships. But when we look at the math, the idea of not having fun at work looks pretty awful. So let's take a look at an average work week, all right? 7 days, 168 hours. And if we look at how that breaks down, we spend about a third of it sleeping, right? And then we've got our free time, evenings and weekends. And the rest of that time, we spend at work. And now this graph here, this is assuming that we have boundaries. Because if we're only working 40 hours, that's what this looks like. If we're actually prioritizing our health and we're sleeping 8 hours per night, that's what that looks like. But for some of us, and I'm not going to point any fingers, sometimes it doesn't work out that way, and it starts to look a little more like this. And I say unpaid work because after you've worked 40 hours, you're volunteering, right? So, work is 24% of your adult life. But actually, that's not even accurate. That's not accurate. Because we all know, we learned in childhood, that sleep is just time travel to the next morning. So work is actually 36% of your waking life. You are at work for a third of the time that you are conscious, from the time you reach working age until whatever age we're finally allowed to retire, which seems to be going up every other year. I know I said this was going to be fun. It's not fun yet. It's going to get there. We're going to get there, I promise. So, I feel like it's important at this point to remind everybody that I'm not your boss. I am not your dad, and most importantly, I am not a financial advisor. I'm just your friend, Jason, and I want to talk about my story. None of this is advice. These are just things that I do that make my life a little bit happier. So, let's talk a little bit about steps to have a good career in tech. Okay, this is a very complicated system. 1, learn some tech skills. 2, get a tech job. Third, minimize voluntary suffering. Some of you, I think, might be at the get a tech job. Who's looking for a job right now? Right. Who's hiring right now? Did everybody take good notes? There's like 2 people in here. Get them. But for those of us who are already working in the field, I think a lot of us are here. We're at these jobs. We spend a third of our waking time there. And we spend most of our free time talking about how much we don't like the work time, which really means that we're spending even more time at work because it's living rent-free in our heads, right? So I believe that our lives are the product of our choices. Okay, so let's take a little philosophy break here, tiny philosophy break. I don't get to choose what happens outside of my control, right? The world is going to happen. I have to live in it. The vast majority of people and companies and weather events and all the other things that happen, I can only, in the most minute ways, influence. What I do get to influence is whether or not I let the things outside of my control ruin my life. I get to choose how I respond to it. So until I can afford not to work, it's out of my control. I have to work. My choice isn't whether I work, it's how I choose to work, right? So we can think, oh, work is a terrible burden. Or we can look at that same job and we can think, work is a fun challenge, right? And these are choices, and I know every work situation is different, and I know I've had terrible bosses, I've had terrible jobs. So I know, again, this is my story, right? I'm not arguing that a bad situation can be a good one. There are times when it just doesn't work. But in a lot of cases, we opt in or out to the suffering. We can look at it as something we can control, that we can change, and we can make choices that make things just a little bit better, right? So I choose fun. I got a long time left in this career, and I don't want to be sad for most of it. So what is fun? In a professional context, what is fun? I see it as the center of a Venn diagram that's got 3 fun factors in it. The first one is I want to be challenged, right? I want to be learning, growing, doing something that's pushing me outside of my comfort zone and making me a little bit better. I want to know that I'm building skills that are beyond the skills that I had yesterday, 1% better every day, right? I want to be exploring. I want to be going places that I haven't been. I want to be trying something new that I've never done before. I want to be opening new doors and seeing what's behind them. And mostly just setting out on new adventures. What new adventures can I go on today? And they can be small. I love small adventures. Can I learn to make a cheesecake? That's a small adventure, right? And little things like that give us a lot of joy if we treat them like that. If we greet every day with like, what little adventures can I go on? That's so much more fun than going, fuck, what do I have to do today? Right? And so the third thing is connection. I don't want to do this alone. That's why I'm here. That's why I want to see all your smiling faces, is because I want to collaborate with my peers. I want to share ideas with my friends, and I want to co-create with my community. This is a core value for me, and it's one of the things that's given me the most value in my life, professionally and otherwise. So if we get challenge, exploration, or connection, any one of these 3 things can be fun on its own, but when we find that project that gets all 3 of these happening at the same time, that's where the real magic happens. That's where we start having real fun, right? So how do we have fun at work, right? Well, the performance stuff is, each of us has a job. You might look at it and you go, dang, that's fun. I wish I did fun stuff. But I want to talk about how you can make just about anything fun, and I want to do that by telling you a true story. When I was at Netlify, it's February, it's 2022, I'm a VP. Our marketing site, our core app, and our docs are in 3 separate code bases under 3 different orgs, and they are different enough that they may as well have been different companies. I don't know if anybody remembers this, if anybody's a Netlify user, but There was a point in time in the early 2020s when they literally didn't even look like they knew that the other sites existed. They were very vastly different. And this was a years-old pain point, but we never fixed it. And it wasn't because we didn't want to. We talked about it constantly. It came up in every meeting. But it was a Gordian knot. Anybody want to give me props for using Gordian knot in a sentence? Okay. It was a Gordian knot of ownership, legacy code, and just shipping pressure that means we always deprioritized it because we just couldn't make time for that. So it always ended up in the backlog. And when we started looking at this project, we had, and I swear I am not inflating this for story purposes, 13 stakeholders involved in these 3 code bases that would all need to be aligned for us to fix this problem. And so, as is my tradition, I volunteered to solve it. And being the very conservative estimator that I am, I estimate like an engineer, I gave myself, by promising to the entire leadership team, 1 week. So, I want all of you to imagine yourselves, this is the situation that you have just been thrust into. You have 3 code bases, 13 stakeholders, and 1 week to unify them into a state that makes it look like they're all from the same company. Close your eyes and just imagine what feeling comes to mind. I'm not hearing anybody say fun. But I'll tell you what, this was the most fun project that I did at Netlify. So here's what happened. I asked our VP of marketing if we could descend on her house in Austin, Texas. I wrangled all 13 stakeholders together. I made them fly in. I also got a number of individual contributors, enough that we were able to do the work that needed to be done, brought them to Austin, Texas. We had about 25 people in Lauren's house. Thank you so much, Lauren, if you're watching this. And we did a 5-day sprint that I named Web Cohesion Week, right? Now, during that 5 days, because we'd brought all of these people together, we worked through years, literal years, of backlog issues. We untied gnarly cross-functional collaboration challenges. We ended up creating a bunch of new shared jokes. Christy, one of our designers, made a logo for the week. We ended up with custom Slack emoji. We ended up repairing strained cross-team relationships. We ended up boosting morale. We built a lot of trust. We increased the team's sense of ownership and autonomy, and we did it while still only working 40 hours. This was not a crunch week. We worked a 9 to 5. We went out and got dinner afterward. We hung out and played games. This was not crunch mode. This was just work. We just brought everybody together, right? But most importantly, all the business speak aside, this was fun. So fun. We got to stuff a room full of smart people, agree on a target outcome, and then take off running together toward that shared goal. We did challenging work, we came up with novel solutions to complex problems, and we did it together. And in the context of work, there aren't many things that sound more fun to me, right? And so it's all in the way you approach these problems. It's all in the way that you look at what you're trying to do. And yeah, work sucks sometimes. Yeah, that manager's a pain in the ass. Yeah, that coworker never wants to do anything. But we can find ways to find the fun. We can find ways to get people aligned, and we can find ways to push things forward where we get that hard work done and we have a blast along the way. So let's do another little tiny philosophy break, because we're gonna move into the next phase of this. Because how did I get that project, right? I mean, I was a VP. I could tell people what I wanted to do, right? So how do you get to that position if you aren't a VP and you can't just go grab the CEO and say, we need to fix this, give me $50,000 to fly 30 people to Austin, Texas for a week, right? I know that not all of us can do that. So instead, let's look at smaller choices that we can make and how we can get there. So a little bit of philosophy that guides me and has guided me for a long time is that your career is a pie eating contest where the prize for winning is more pie. And that can be really depressing, or it can be the best news ever. And so I think if you take it in the positive context, You just want to be extremely clear about what kind of pie you like. If you put work out there that shows people what you can do, that shows people what you're capable of, they're going to offer you that work, right? And you can do this in several ways. If you're on the clock, you can volunteer for projects that put you in the direction that you want to go. Do you work on a team, but you want to work on the design system team? Maybe you can volunteer to help them when they're a little stretched thin and you've got a bit of extra bandwidth. Do you want to move into R&D? Maybe just build a little something that you can show to the R&D team as you notice a problem with something that you work on in your product org, right? Or if you have the luxury of spare time outside of work, build little projects that show people the kind of work that you would like to do. That becomes the resume. That becomes your menu. People see the project and go, oh, you did that? Can you do that for me? And that starts to steer you toward the type of work, the career that you want to build. So I want everybody to get your phones out because I'm going to put this up only for a few seconds on the next slide. This is the whole secret. I'm going to tell you the whole thing. And I don't want you to miss it. This is the entire secret to my career. But yeah, I'll hold for applause. I have spent the vast majority of my career using little pockets of free time to build silly shit to make me and my friends laugh. And it has made all of the difference in what I'm able to do with my career now. And there's really good science behind this, actually. Play makes us better at learning, right? If you spend all of your time being terrified that the tech is going to change out from under you and the robots are going to take your job, and what if you wanted to learn React, but now everybody says React is bad, you have to learn Svelte or Solid or something. Wait, I just finished learning how UseEffect works, and now they're going to take it away from me? Oh my God, right? That is not a positive learning environment. You are not retaining a lot of information. You're so locked down with terror that the new information is just bouncing off of your brain, right? You're batten down the hatches at that point. If you're having fun, you'll learn things really quickly. This is why we're usually pretty good at learning things like video games, board games. If your friends want to play a game, you can pick up the rules pretty quickly. It's because you're open to it, you're enjoying yourself, and there's an incentive then to keep taking in information and retain it because it makes the game more fun. You can do more if you know more of the rules. That is magic. So you get increased engagement, you get better retention, you get higher resilience, and you get lower stress, right? When you're playing a video game, you die all the time, right? You may have seen, I just talked to Rachel Lee on my YouTube channel about this, and she gave me my favorite metaphor for life, which is to treat it like a video game. You can't fail. You just go back to your last save point, take what you've learned, and try again. You get to keep that knowledge. If I go try something and I fail spectacularly, cool, whatever. I'm gonna figure out what went wrong. I'm gonna decide if I want to try again. Maybe I'm too embarrassed to try again. Maybe I'm gonna change and go this way instead. Or maybe I just realize, you know, if I had done it this way instead of that way, I think I could have gotten there. Let me try, right? And then you get to go and do it. You're more resilient because you're having fun. So I want to show you a few of some of the dumb shit that I've built. So this is a project called ESLint Reply Guy. And this is an ESLint project that contradicts itself. You can't win. And this is one of my favorite things that I've ever built because it's one of the only times that I got the community really excited to contribute. And a bunch of people showed up and contributed rules. And most of them were built on actual Twitter conversations, which was delightful. It was great. All right, now check this one out. This is another one of my favorites. You remember the Untitled Goose Game? So that project just hijacks all the links on a website and makes them honk instead of actually working. I thought this was really funny. And you can see here how people felt about it. My friend Jessica Tremblay was like, nobody asked for this. My friend EJ Mason said, this is the worst thing you've ever done. And they were right. And it made me so happy. That was like one of my favorite couple of days on Twitter because people were just having a blast with this and just ridiculous. I was getting ridiculed so hard. I have a live stream. I pair program with people for 90 minutes. This is an older iteration of it that I've since turned off because, as you can see, it gets a little distracting. But I wanted to see what would happen if I made it so that every time you used an emoji, that emoji that was used would fall from the top of the screen, bounce around, and then settle at the bottom of the screen for a few seconds. What I thought is that every once in a while, an emoji would fall. What actually happened is Cassidy Williams is a terrible person and would rally everyone to spam the boop emoji until we could no longer see the guest on screen, which is why I turned it off. So thank you, Cassidy. You ruined fun. But I want to go back and I want to look at some of the things that I learned on these, right? So if I go back to this one, I learned how to build an ESLint plugin. I learned about static analysis. I learned really core skills that taught me how to do useful things in the pursuit of trolling my friends, right? With this one, I'm going to skip it before it plays that sound again, but with that one, I learned about how to control the DOM. I learned about how to, take click events, how to add event listeners, remove event listeners, how to play audio in a way that was performant, and well, it wasn't performant, don't look at the code. But I learned things that I've actually been able to carry forward. I learned how physics work. I dropped out of math, like that's not my thing. I learned how to code physics here so that I could make them bounce and kind of interact with each other on the screen. I learned how to do different animation things, and I learned real time. I had to figure out how to get IRC events into JavaScript on the web so that I could do something goofy. Every single one of these things was highly applicable to future projects. And so my silly personal projects help me land fun professional projects because people see the silly shit that I build for fun and they say, we want that for us, and we have budget. My silly personal projects help me build wonderful, inclusive communities. If you ever show up on my Discord, if you ever show up on one of my live streams, if you show up in a group that I'm in, we're going to be welcoming. We want you there. We're excited to see you. You're not going to get judged for your choice of tech. The only thing that's going to get somebody in trouble is if they come in and they're not tolerant of somebody else. And you get that by putting it out there, right? It helped me unlock an entire career path. This is my job. I get to make this for money. Somebody gave me dollars for that. I dressed up Phil Hawksworth like a fucking robot. This is incredible. Look, this is my job too. This is us playing D&D. You might notice that that's my wife, Marissa. She's here somewhere. Hi, Marissa. There she is. She's a much better actress than me, so I usually give her the lead. And also, if you want to hire me, you can. That's the link. Just everybody who needs to take a picture, got it? So, a couple caveats. I think sometimes people talk about fun like fun is the opposite of hard work. That couldn't be further from the case, further from the truth. Because level of enjoyment is a sliding scale. It can be fun or not fun. And level of effort is a sliding scale. It can be hard or not hard. Those are completely unrelated metrics. You can do extremely hard work that is extremely fun, and you can do really easy work that sucks. Most of us have done a lot of the really easy work that sucks, right? So why would fun work not count? Why would fun work not be hard? Just because it doesn't feel hard doesn't mean it's not challenging. So all of this just brings me to send you off into your evening, or I guess into the next talk, because we got one more, with just a few messages of love for you all. I want you all to try to find a way, no matter what situation you're in, to follow your heart, to follow your curiosity, to follow things that give you joy, to follow the fun, and, most importantly, to follow, like, and subscribe. Thank you all so much.
Guys, we made it, our very last talk of the day and the conference. Yay! Unfortunately, Sean has some visa issues, so he can't be here, but there's going to be recording. But I guess, hi, Sean. I'm still going to do the intro as if he's here. So here it goes. Guys, I've been seeing things lately. So I met this guy named Sean Wicks Wang at CascadiaJS 2 years ago. And since then, I haven't been able to get rid of him. I was reading an article on Tailwind. He wrote it. React subreddit. He ran it. And the Svelte Society. He started it. I'm telling you, he is everywhere I go. And that's when I realized that Sean is such a prolific writer, conference speaker, and now he is the founder and CEO of Small.ai. He is a true champion of what it means to learn in public. For the last time of the conference, give it up for Sean Wicks Wang.
Hi everyone, this is Wicks. I'm so sorry I couldn't join you live. I was supposed to attend, I had bought my tickets and everything, but I was prevented from coming in through a series of very unfortunate events. We can talk about it more offline, but here I wanted to still give you my best on the state of AI engineering. I'm very fond of CascadiaJS, which is why I'm going to say yes whenever I'm invited to speak, just because I just love this community and family so much. It's a real bummer not to be able to attend. But just to kind of recap, the previously on in sort of Swixverse. In 2020, I talked with you more about my career stuff, just because I had just published a book at the time, and I had a lot of learn in public and operating system thoughts that I wanted to share with people. Then in 2022, I was sharing more about my technical opinions, and actually I still hold very dear my speaker pass and attendee ticket from when it was in Oregon in the Sun River Resort. That was a really, really special moment as well. This year, we're back in Seattle, and I'm really excited to be sharing with you my thoughts, my updated thoughts on AI engineering, because it's really changed my life, and I do think this is going to be a topic of a lot of conversation from you guys, and I'm sure you're interested in what we're seeing in San Francisco as well. So this whole piece and my entire, I guess, credibility of why I'm talking about this to you today is because I wrote this piece on the rise of the AI engineer. And it really set off a series of events that culminated in me effectively pivoting my entire career to this. And I do think a lot of people are sort of in the process of this right now. And I wanted to show you the more important things that you should know about that. The central thesis is that foundation models and the rise of the large API labs effectively are enabling a big shift in how ML is being deployed into production. So in 2013, there used to be this popular XKCD meme where to do a very specific task, you need an in-house machine learning team. But roundabout in 2023, the state of AI progress is that you can change some few prompts and take the performance of something from 17% on a benchmark to 78% on it, just by adding that thing step by step. So that's kind of a meme. That's obviously one very, very narrow definition of progress, but it is progress, and it is, I guess, an indication of how things have really changed in terms of the kind of ability that you need for increasing the performance on a specific domain. We used to not have foundation models, and now we do, and now we can take them off the shelf from a lot of large model labs. Increasingly, I also find that people are asking questions about how to get started in AI engineering. This is a Hacker News thread that was fairly popular, and the common answers are either you go down this classical sort of machine learning path, or you go down the data engineering path. Since I left being a pure JavaScript person, which is heresy to talk about in a JavaScript conference, I have gone down a little bit of both paths. Right, I did a machine learning specialization in Georgia Tech, and I worked at a data engineer. And I can healthily endorse and qualify the statement that doing both of them doesn't necessarily set you up for a really successful career in AI engineering. So if that is broken, if that concept is broken, then what really is it, right? So this is the primary image to have in your head around defining AI engineering. Typically, you have the more established roles of ML researcher, ML engineer, and now there's sort of an API wall. This has always been there, but what that used to be occupied by on the other side was just a full stack engineer, product engineer, and that kind of stuff. But now that there is an increasing velocity of development in AI, what I'm seeing emerge is a dedicated role that is focused on keeping up and knowing the best practices, and that is coming to be termed the AI engineer. I think the other thing that's important to note as well is that the API wall is actually increasingly the wall between companies. It used to be the wall between teams internally within companies, but now it's between companies because the sheer amount of investment involved in the GPUs and the research capability and the staff and the data is all being walled up into the large foundation model labs. And now they want to serve their models as their products to the rest of the companies building the sort of last mile to the end user. So this is a very much of a demand and supply issue. And the two people that I quote now are Andre Karpathy, who says that there's going to be more AI engineers than ML engineers. And the other person is Ben Frischman, who is the founder of Replicate, also saying that there's basically about 2 orders of magnitude more AI engineers than software engineers, than ML engineers. And I think this is just true. You just simply don't need the level of qualifications that a typical ML engineer has. But also, I think that's more of a statement of lower social class, maybe, that the sort of entry barriers to entry might be lower, but actually there's also a lot of opportunities, because the kind of person that is a good AI engineer may not be the same kind of person that is a good ML engineer. It's very much of a 0 to 1 mentality rather than a 1 to n. So I covered a little bit of this earlier. Here's just some charts. This image is from the Stability AI fundraising kickoff back in the day when Stability AI was the hottest company in town. But they actually started the sort of GPU arms race where entire startups would just raise money just to reinvest in NVIDIA chips, and that's definitely going apace. And there's also a sociological issue in the sense of there's just a lot of interest. This is my old company where we used to have one AI channel, and then we had more and more AI channels in my Discord, and now my Discord is just entirely an AI channel, right? It has definitely eaten and consumed a lot of people, and there's just a sheer growth in the amount of people wanting to work in AI that don't have the traditional background, that actually don't need the traditional background in order to be successful with it. I do also want to emphasize that it's not just like the why now of this. It's not just enabled by people's interest and hype. I think there is some real substance behind it because of the ability of foundation models to generalize across a lot of domains, to be specialized by prompts, and to do in-context learning with a lot of examples. So over here, this is an example that was taken from the GPT-3 paper, which I highly recommend reading. And on the right is on the vision domain with the segment anything model paper from Meta. Both of which all indicate the ability of foundation models to generalize very rapidly and then specialize with in-context learning. All of which means that you don't have to train the foundation model yourself. You don't have to build a team internally within your company to do that. You can grab one off the shelf, open source or closed source, and use AI engineers to do the tasks that a whole team of ML engineers used to have to do in the past, and do a better job than they used to do, because you just have much more data, and the foundation model is generalized much better. Okay, the other thing I really like about sort of product sensibility is that we shift from a mindset of ready, aim, fire to fire, ready, aim. And so in what that means in the ML context is that you go from data, you collect a whole bunch of data, then you train the model, and then you serve that as a product. That used to be what a traditional sort of MLE process would look like. Now, with AI engineers, you MVP a product first, and only if that MVP is successful, then by sheer usage, you collect a whole bunch of data that's specific to that MVP, and then you can custom tune or train your own model, and that's the sort of a complete inversion of how the time to market has really shifted with AI engineering. It's really, really fascinating. The last piece, and the most relevant for CascadiaJS and the JS community in general, is that this is the first time that we've really had the opportunity to dabble in JavaScript, right? Like we used to have TensorFlow.js. I used to make fun of the TensorFlow.js talks in conferences. There will always be one, and there would always be some really, really sad demo here and there. But now it's actually getting real and getting serious, and you can't really ignore it. I would say definitely Vercel has pivoted very, very nicely into owning the sort of AI TypeScript engineer. Here's Guillermo Rauch talking about how he believes that that the future of AI engineering is TypeScript. I will say that expectation has not really played out just yet. Here are the graphs of LangChain in Python and Vercel in Python and Llama Index in Python versus there are JavaScript and TypeScript equivalents. Definitely, by far, I'm finding that AI engineers will learn Python instead of rewriting the world in TypeScript, because Python is not that hard to learn. So that has some implications for the future of language-specific conferences versus more industry-specific conferences. As you might know, I've started my own conference that is language agnostic because of that. Okay, so why engineering and why not prompt engineering? Why this term AI engineers? I just want to give you some perspective on that. There's a very common and well-known progression from software 1.0 to 2.0. This very famous piece also by Andrej Karpathy talking about what software 2.0 is. And basically, it's instead of hand-coded if, thens, and loops, you learn them through a whole bunch of data by setting up an architecture and just running them through with a normal sort of learning pattern. Software 3.0 is slightly different, where you're taking a foundation model and actually programming it, in sort of post-training it from there, usually using in-context learning or prompting, as people might call it. I actually talked a little bit about this in my last CascadiaJS talk. So you can go to the 2022 talk that I did to find out more about that, because I'm not going to spend a whole bunch of time on it. The evolution that I've had since then is this core insight, is that AI plus code is actually way more powerful than AI plus language. And that is something I want you guys, all of you watching, to really internalize and understand. In that software 3.0 can generate software 1.0 code, and that is actually much more powerful than any sort of foundation model working by in and of itself, right? So the best way to see that is the ability of LLMs to write code and augment their own abilities with code. In September 2022, we were just figuring out how to hook up GPT-3 to a calculator and a sort of Python REPL environment. By June 2023, this is when the general availability of OpenAI's code interpreter was released, and now you can generate all these charts and not need to know how to code, because the LLM can code for you, and that's just really fascinating. To me, this represents a big part of the progress, or the future progress of all these LLMs. If you can see that between each major version of an LLM, a core fundamental insight has really introduced that level of growth. Between 3 to 3.5, it was instruct tuning, and that spawned ChatGPT. Between 3.5 and 4, it was the mixture of experts that caused a huge jump in capabilities. And between 4 and it's effectively 4.5 or 4.0, it's the ability to write code and to operate in other modalities as well. But code is the most important modality by far. I'll skip this special piece, but I do think that understanding like where the significant value is accruing. We started off with GPT-3 with GPT-1, 2, and 3 with pre-training, but it's increasingly going towards the reward modeling and reinforcement learning that is driving more and more of the value. I think the latest numbers that I have heard, which is that Llama 3's core pre-trained data set versus their reinforcement learning and reward modeling data set, they're spending about the same amount of money, whereas it used to be a lot less money on the sort of post-training sections of their reward modeling. The other element of the sort of software 1.0 plus 2.0 equals 3.0 thesis is that there's a really core schism when you write these apps about where code should live, right? A lot of like the ChatGPTs of the world are really essentially a thin wrapper shell around a LLM core. They basically translate user input with whatever affordances into something that is just piped out into a string and fed to an LLM, and the LLM decides and then spits it out again, and that's about it for the application. Increasingly, I'm finding that people run into limitations because this application is only as smart as the LLM will be, and really it's unpredictable, it's unsafe, and prone to all sorts of issues. Actually, you want to break things up and switch towards a code core thing with sort of LLM at the shell or LLM at the edges, and that actually might serve you a lot better. So I do want you to understand as an AI engineer this fundamental distinction that it's very good, it's very useful to do both, but having an idea of what kind of architecture you want to adopt is probably one of the biggest decisions you'll make as an AI engineer. Finally, the sort of emergent architectural discussion around AI is the concept of the LLM OS. I had an early version of this in a piece called The Anatomy of Autonomy, but nowadays I'm probably encourage people to not use human brain analogies because LLMs and artificial intelligence evolves very, very differently from natural intelligence. In fact, I'll push you more towards the sort of operating system analogies because they have much more physically constrained limits, and it's much more conducive to think about engineering from that point of view. So LLMs all have context windows, and then basically you have to page in context in and out of the context window with a broader corpus of retrieval augmented generation databases. But then you also want to hook them up with tools. You want to have different input devices, and then you want to connect them up to the internet and other LLMs. I think this model really, really holds. If you look at the literature of how we structure my course on the InSpace University, we basically follow that exact guide and tour through the modalities. And finally, we also talk a lot about the sort of four wars of the AI stack, right? Like what people are really fighting over, and what are the unknowns that will be basically the substance of what people are fighting over the next 5 to 10 years, let's call it. So people will be fighting over data, people fighting over GPUs, people fighting over whether you have a lot of different models or one single God model that does everything, and people will be fighting over RAG and ops. Here are the main players within that space. I definitely refer you to that InSpace piece if you want to read more. I don't really have the bandwidth here to discuss it because it would be its own. And we've already done a bunch of versions of those talk. My goal here is to give you an overall state of the state of AI engineering, right? Which I think is why I'm here. So when I was in this sort of data engineering world, which is last time in Cascadia 2022, I always talked about this whole overwhelming stack that people like to put out there. And I always want to encourage people, if you want to make sense of a landscape, to always simplify, right? So this is what I did in 2023 for the modern data stack, which is instead of all those confusing diagrams, like just take the things that are actually valuable. Instead of weighting by number of logos, you weight by amount of value, like economic business value actually created, and you simplify a lot to warehouse pipes and business interface, and then a whole bunch of observability and ops stuff that isn't as valuable in AI. Okay, so what is the equivalent for the AI stack, right? In 2023, I did this, which was foundation model labs. So basically closed source labs and open source labs, or open source hosting. There's pipes as well, and there's vector database, and then there's the user interface, right? And we can talk about the main players of each. So you need to know, for example, I expect every AI engineer to know these names on the left, these names on the right for hosting your models if you're open source, or choosing your models off the shelf for closed source. And then these names on the left for vector database, and these names on the right for coordinating with those vector database. These are sort of the RAG frameworks. And then finally, the last piece is sort of the most emergent piece, which is the ops stack. There's a lot of sort of operations names as well. I will stand by all of these as names to know if you're shopping for your sort of ecosystem of AI engineering tools. And they all look like this, right? Their landing page all looks like, we will track your prompts for you, and we will tell you how much you've been spending. Not have any opinion about how you should be building your products because they're trying to build a horizontally applicable tool. The most interesting for JS engineers and UI engineers is still up for grabs, surprisingly, even like 1 year after I made this original chart, which is like, what is the user interface of AI, right? A lot of people are talking about chatbots, but I think people are increasingly coming up with new and useful tools that are not just chatbot. So Vercel V0, I think a lot of people at this conference will be familiar with, but it's really good for prototyping UIs. I think it should be a part of the core toolkit for most AI engineers as well, for anything front end. And second, for internal facing tools, I do think that you want some kind of UI interface to chain things together. Retool AI is really good at it, but there's a whole bunch of others, Langflow and BuildShip and all the other startups that are all canvas-based UI elements. If you're interested, I have held a AI UX meetup where people have shown off their latest and greatest in those tools, and they're on YouTube as well. Okay, so coming back to the LMOS, I definitely recommend these two folks, one still at OpenAI, the other one ex-OpenAI, just talking about their sort of OS experience. But really, I would actually direct you towards the evolution of ChatGPT, and maybe now Anthropic as well, which is that every single one of these like toggles and buttons within like a new GPT creation process is a startup and is part of the LLMOS, because they all have independently discovered the need for one of these things. So for example, you need a knowledge base, you can use a vector database, or you can use an orchestration framework. If you want to hook your LLM up to the internet, you can use Perplexity, browser-based, or Exa. If you want to have image generation, you can use any of the image generation companies. Same for code interpreter, same for hooking up with external APIs for Zapier. An increasing important thing for long-running agents and personal assistants is basically the concept of a memory agent. So memory is an emerging field. I would encourage people to check out LangMem from LangChain and MemGPT, which is a paper that's now become a startup. This is much more speculative. On the stuff on the right is much more speculative than the stuff on the left, but I think it's also really worth checking out. The final piece is just security, which I'll call out here. There's obviously a lot of things to call out, including speech and other controls. But security, I do think it's underrated and something that builders always want to leave towards the end. But having an important sort of security component that solves everything is really helpful. A friend of mine just got acquired by OpenAI just to provide this layer for all of OpenAI. But you can check it into Anon if you're interested in security. More broadly than that, I think domain-specific ChatGPTs have really been the story. This is a story I did earlier this year, talking about why in the past 1 year, in the past 12 months, ChatGPT's numbers or user growth numbers have been zero. There's been zero growth in ChatGPT because people have been unsubscribing. Like I have unsubscribed from ChatGPT myself. And because I just find so much more domain-specific use cases that actually do what I wanted to do. So the GPT App Store actually might be a better place to hunt for business ideas than actually writing GPTs and trying to earn revenue from ChatGPT itself. So I really encourage you to look for opportunities in all these areas because the LLM OSs of the world, which all these components, that ecosystem is really maturing for the AI engineer to build their own part of the kingdom instead of everything going into ChatGPT. I will also note, I guess, that OpenAI is completely fine with this. They have no issue with enabling their own competitors because it's not about making money from ChatGPT for them. It's more about making intelligence available to everyone. Okay, so where to start? A lot of people ask me this. We have created our own sort of little course that is taught on Latent Space University because we want to trigger the Tigers fans. But also, we also teach a live cohort session on maven.com, which is starting. What about AI engineering in industry, right? Where instead of if you think everything I've talked about is very basic, how do you learn from the best? I actually happen to be organizing my own conference now. Going from conference speaker to organizer is a very, very big jump. And I'm not sure I'm ready for it, but whatever. This is my conference that's happening next week. That is basically serving the field of AI engineering, and I've invited the best of the best from every single industry and domain. And that's about it. I wanted to make this remote talk short. I'm very sad and apologetic that I couldn't make it in person, so I wanted to give you back that time. Then also just tell you that I'm still here. I'm still online. I'm still easy to access and talk to. Find me at AI Engineer or find me at Latent Space, my podcast and newsletter. Thank you so much, and have a wonderful CascadiaJS. Thanks.
All right. Wait for the AV to work. By the way, you're not going to believe this. That entire talk was generated by AI. Yeah, I know. Man, this is does anyone know how to turn private relay off? I'm just kidding. This is a really bittersweet time of the night. It's one of my favorite times of the night because I get to come on stage. Just kidding. No, it's sad because this is a closing time. By the way, if you're under 40, this was a band called Semisonic. They had Oh, by the way, like if you're sticking around for karaoke, like this is like a pretty hot karaoke song, so you can sing it. But yeah, it's time to close things down. But we're going to start off with some fun first. So a bunch of you completed the scavenger hunt. Give yourself a round of applause for doing so. And we are going to use technology and code to pick winners. So this is really fun. I'm going to invite all of the sponsors who have prizes one at a time on the stage, and we're going to do this. So why don't we go ahead and start off with Stitch? Why don't we hop up here? So how are we going to do this? So the way that we're going to do this is I'm going to show you some code, and we're going to talk about it very, very briefly. This is the code. When you all scanned that QR code, this is the code that I wrote to put to sort of turn your information into something called a vector embedding and insert it into a vector database. So I know that a lot of you have already heard this story, but I'll say it again. So a vector is a representation of information, right? And specifically, it's a really long array of numbers. And we're actually going to see some vectors in just a second. So if you can kind of visualize a vector representing a point in like n-dimensional space, like the vector for the word dog might be right here, and the vector for the word puppy might be right here, and then the vector for the word truck might be over here, right? So there's sort of, you just got to imagine these vectors as these points in space. And what we're going to do is we're going to play a game where we're going to build random strings, and we're going to create vectors for those random strings, and then we're going to see whose raffle entry is closest to these random vectors that we create. So the way that we're going to do that, so I'm not sure who's going first, but either Andre or Daphne is going first. Daphne is going to pick a random person, and we are going to start constructing a random string. And then we're going to run that random string through this code. So let me talk through this code. What's happening? We're using OpenAI. We're npm installing OpenAI, and we're using their model called Text Embedding Ada 2. And then we're going to take this random string we construct, and we're going to turn it into a vector. So let's do that right now. So Daphne, go choose a victim.
Eve, I choose you.
Fantastic. And we're going to run this script, and we're going to start constructing the random string. So this is impossible to game. Whoever wins is going to win fairly. I will say the only rule of the game is that you can't win twice. So Daphne, Daphne's got the mic. Daphne, go.
All right. Tell us your name, and I'll ask you the 3 questions. What's your name?
Eve.
Okay. Tab or spaces?
Tabs.
All right. Next question.
Okay. Next one. What's your favorite framework?
Next.js.
All right, let's go.
Who is your favorite MC? And there is a right answer.
You, obviously. Obviously you, Daphne.
Thank you.
The best Daphne. All right, so boom. So this monstrosity is a vector. And we're going to copy this vector, and we're going to switch over to the best vector database from DataStax. And we're gonna run something called vector search. So this is what the DataStax console looks like, and these are all your entries. And I'm going to paste this entry in, and I'm going to click apply. And look, you must be present to win. So like whoever bubbles to the top, if you're not here, so sad, you don't win. So 1, 2, 3, apply. Hold on, we'll say that in a second. Okay, is Jem here? Jem! Come on up. Come on up. What has Jem won?
AirPods.
Yes! All right. Yeah, wait, hold on. Where's the... Oh, wait. So make sure to get a picture with... Hold on. Yeah. Get the photo up with the photographer. Yes, please present the prize. Okay, so we're going to keep the party moving because we've got a lot of prizes to give away. So I will invite to the stage the next person to the stage. How about sorry, I need to Infobip. Infobip, where are you? All right, Infobip. Welcome to the stage. All right, now I'm going to do something that's going to blow your minds a little bit, but that's just how cool technology is, and I'll explain it later. Okay, so now we've got Andre. Andre, go find your victim. And by the way, what are they playing for?
An R2D2 Lego set.
R2D2 Lego set, fantastic. All right, so I am ready to go, Andre, whenever you are.
All right. Hello, new friend. What's your name?
I'm tearing it up, Baines.
All right. To start off, where are you from?
Vancouver, BC.
Whoop whoop.
All right.
Amazing.
Hold on. I got to type. Vancouver, BC. All right, go.
Cool. All right. Barbie or Oppenheimer?
Oppenheimer.
Oh.
Okay. Respect.
By the way, the correct answer is Barbenheimer. So.
Trick question, sorry. And last but not least, AI or Elon?
Down. AI.
All right, good. That's the right answer, by the way.
Thank you for participating.
You would have been disqualified. Okay, so you might be asking, like, Carter, what's happening? You're typing a bunch of text into this search field. I thought you had to search for vectors. That's true. However, this collection in our database is already pre-configured with, in fact, hold on, check this out. Boop. Double click. There we go. It's already pre-configured to use text embedding Ada2. So right here in the console, when I run these searches, if it sees that it's not a vector, it will run it through that embedding model and then do the vector search. So once again, 3, 2, 1, you can't win twice. Justin Meddy? Yeah! Come on! All right, so you can come over here. So just, all right. Oh, no, I mean, just it's all good. Right, like right here is good. Yeah. Justin's going to pop up. Don't hurt yourself. Get the photo up. Excelente. All right, let's keep the party moving. All right. Who's my next victim? How about temporal? Where are my temporal people at? All right, here we go. All right. Welcome to the stage, temporal. All right, and what do we have here? Oh, Lego is a popular swag item. All right. Oh, yes, the famous ornithopter that I did not know how to pronounce. Looks super cool. Okay, Daphne, who's our next victim?
Hello, friend. What is your name?
I'm Alan Deutsch.
All right.
Hi,
oh, Alan, you're presenting at the startup fair.
Oh, wait.
Yeah.
Does that
okay. So
make him ineligible for this?
No. Remember, he's not necessarily winning anything.
Oh,
he's
that's
just sort of
true.
like this puppet that's going to say words.
Okay.
So, all right, let's go.
Okay, just because the last person said Vancouver, BC, Seattle or Vancouver?
Seattle.
Okay. I like that.
Pickle or ball?
Pickle.
Okay. Drake or Kendrick?
I'm gonna go with Kendrick.
Kendrick. Wait, I didn't hear that. What?
Kendrick.
All right. So without any further ado, 3, 2, 1, the magical vector search, go. Kyle Cordell. Do we have a Kyle Cordell? All right. Come on down. All right. All right, and then photographer's right over there. Hop on up, Kyle. All right, fantastic. All right, let's see. Who am I missing? Codingscape. Codingscape, come on up here. Round of applause for Codingscape. Awesome. And I believe we're back to Andre. Andre, have you found your fun guest player?
Yes, I have. First, tell us, what's your name?
Christina.
Hello, Christina. All right, first question for you. East Coast or West Coast?
West Coast.
All right.
The best coast.
Next question. Android or iPhone?
Android.
Android. I got some applause.
And finally, Twitter or Mastodon?
Mastodon.
Oh, there you go. Yeah. Whatever, I can't spell it. That's probably right. Okay, all right. And what are we playing for?
a beautiful backpack.
Awesome. A Cotopaxi backpack. Fantastic. All right. 3, 2, 1. Ignition. Lance Warwick. Where you at, Lance? Yeah, baby. All right. Go right over there for the photo op. Lance is our awesome pickleball ambassador, so couldn't have gone to a nicer guy. All right. Fantastic. Okay, so we're wrapping this up. This is working better than I could have possibly hoped. Where's my DataStax people at? There we go. Everyone, welcome Sri to the stage. Sri is a summer intern. So she's in college. She's a summer intern at DataStax. She's a summer intern on my team. What are we playing for, Sri?
We're playing for this awesome looking glass portrait.
Yes, the looking glass. This is, I kind of like, you know what? I think I win this. So, all right, just kidding. Okay, so we're back to Daphne. All right, let's give away our final prize.
Hi, friend. What's your name?
Jacob Andes.
Hi, Jacob. Okay, first question. Beyonce or Taylor Swift?
Beyonce.
Beyonce. All right.
They're both queens, to be fair.
No wrong answers there.
Uh-huh. Okay, if Zuckerberg and Satya are in a boxing match, which one of them will win?
It's a hard question, but I think I'm going to go Satya.
All right.
Okay, the last question. What is the best conference ever?
CascadiaJS.
Oh, Daphne, God damn you. All right. Thank you, man. No, the crying comes later, Daphne, not right now. Anyway, okay, 3, 2, 1, magic, go. Oh, who is this? Are they here? I can't pronounce it. Giovanna? Yay! Come on! All right. Yeah, and there's a ramp too. There you go. No worries. All right. Fantastic. Oh, let me zoom back out. So bad at these gestures. There we go. Yay! All right! All right. No, thank you. All right, awesome. Thanks, folks. Thanks for playing along with the game. Back to regularly scheduled programming. All right. The closing party by DataStax. I hope all of you are sticking around tonight. I can't imagine why you wouldn't. This is our closing party. It's going to be super amazing, super fun. Thanks to our friends at DataStax, we have a photo booth that's going to be set up any minute now. We have the best karaoke DJ in the entire Pacific Northwest who's going to be running karaoke here tonight starting at 7:30. Quick note, kind of like yesterday, if you have a green or yellow badge, don't worry about the drink tickets. You're good to go. That being said, sorry, I'm going to be a dad. Please don't overserve yourself. We want to be able to come back here, so be responsible. Don't make me regret getting rid of the ticket limit. If you have a no frills badge, please stay. Like, this party is for you, and they'll run a cash bar, so you can buy your own drinks. So stick around, have fun with us. But yeah. So this is my sort of traditional end to the conference, and I've never changed it, and I never will, because this is the most important part to me about what needs to be said at the end of the conference. And by the way, I usually use the word thanks, but recently this really awesome person named Tejas Kumar joined my team, and he actually created a channel on our Slack called Gratitude. And he's been inviting people at our company to post in it when they feel really grateful about something. And it's just such an awesome thing. So Tejas, if you're out there, I changed this slide because I love your spirit, and I appreciate it. So I want you all to prepare to like wear your hands out because we just have a lot of thanks to give. So first of all, I want to thank all the people and companies that contributed to our scholarship fund this year. I'm not going to lie, like we had a hard time raising money for scholarships this year. Like I think you all know, like things are just a little bit lean, a little bit maybe different than they've been in years past. But every single one of these people either donated some money or deferred something that they could have gotten in order to help us be able to include more people in this event. So a big round of applause for all of them. This is the slide everybody expects, right? It's like, yes, of course we're an event. Yes, of course we have sponsors. Our event, like absolutely 1,000,000% could not happen without the incredibly generous support of all of these sponsors. And look, like there are ways to sort of to get more sponsors and to get more money out of sponsors, but like we run our event in a certain kind of way because we are unwilling to compromise the experience that we create for all of you. So what I love about our sponsors is that both they're all sort of really awesome companies who have amazing people who work there and who have interesting products that I think you all should learn about, but also like they are the first people like in my inbox saying like, how can we support CascadiaJS and how can we support your community? So a huge round of applause to these sponsors for helping us. For every 25-minute talk, and maybe every 10-minute lightning talk that you saw, every single one of these people spent 100 hours or more, like putting together these talks. And we do not pay speakers to speak at this conference. I would love for the circumstances to be different so that we could, but we can't. We do our best to take care of them and make sure that we cover things like travel and hotel. But for the most part, every single one of these people decided that they wanted to help make this event amazing, that they had something that they desperately wanted to share with all of you, and frankly, completely separate from the talks that they delivered on the stage. Every single one of them was reaching out and doing things behind the scenes. So you all are here. You know why you're here. Help me thank our speakers with a huge round of applause. I'd like all the organizers, everyone with a yellow badge or a green t-shirt, please join me on stage. Come on up. Hold your applause. So, I use all the cliches, it takes a village, there's all these things you can say about what it takes to put on CascadiaJS. These are things, I think, I don't need to repeat myself. I think what I want to say maybe that's a little different, and maybe that I haven't said exactly in this way in the past, is that I can't express to you how great it feels to get to work with these kinds of people on this kind of event. If you've never, we're all busy people, right? I don't know, if you've never volunteered, in your life, if you've never just put yourself in a position to sort of volunteer your time and work with someone who cares and have it not be part of your job, I beg you, go find that opportunity, right? Go find an opportunity to do something from your heart and to do it with other people who are doing it from their heart, because the feeling is unbelievable. I'm watching these people run around and like kill themselves to make sure that people are taken care of, that people are like looked after, that like, oh my God, somebody needs something. Like, it's like crazy. It's like working with superheroes or something. And like, anyway, and selfishly, like the feeling is like, it's like the best drug in the world. I encourage you to go have this feeling later. But right now, please help me thank these people for making CascadiaJS possible. You guys are killing it with the clapping. You're killing it. Like, I'm stopping, and you're like, fuck that guy. Like, and then cutest picture of the conference. Some of you have come up to me and said really nice words about, like, thank you. And by the way, like, I hope you're saying those things to them too, right? Like, I'm not being modest. Like, I don't do that much, like I just sort of like, I don't know. I'm a guy that like started a ball. I started rolling a ball, but then like all these other people showed up to kind of push it, right? So, like later tonight, like if you haven't expressed your gratitude with someone about this event, like, yeah, you can tell me, I love it, but like tell somebody else, right? But anyway, but the point is, like, you don't understand like how important that is, and I think many of you might not understand like how important all of you are to this conference being amazing. Like I hear a lot about how people have enjoyed their experience and like, oh, these about the things that they like about the event. And I think that like what is sort of left unsaid, and there's a kind of a magic to it. Somehow this conference tends to attract really great people. And I don't know how. I don't know if it's like how the website is designed, or maybe it's like a networking effect thing. Like, we kind of did a good job early on, and word of mouth kind of happened. Like, I actually don't know how to put it into a bottle. I don't know how to bottle it, right? But like every single year, I'm just like, Jesus Christ, the people who come here are so nice. They're so nice. They're so awesome. They're not just awesome to me. I see you being awesome to each other. And so anyway, I don't know what it is, but keep doing it. Because you all collectively help Cascadia be amazing. We are so grateful for how awesome you all have been. So thank you so much. All right, so nobody get up that's here. I'm now going to say goodbye to our friends on the stream. Farewell, fare thee well. We hope that we can see you next year, and we'd love for it to be in person. So take care, have fun. And some stuff's gonna happen on the internet now. Now, this is mission critical shit, right? It is now time for us to do the